Welcome to Prelim Preparation 2026. So this is going to be your preparation to this year's trial. Reason why I did this is that I went through the past papers for trial. They're a little bit trickier compared to the normal November paper. So I wanted you guys to be well equipped for your trial, as it contains a lot of marks in terms of like your final mark. So, and also the nice thing is that if you can master this and if you can do well in your trial exam, that means the fact that your November you have less stress. So that is why I decided to do this. So I have a recording schedule, right, or a release schedule on which when each paper is going to be released. So the preparation is going to start now, as you see in this video. So this is the release schedule, right? So it's within each date. So as you can see, the fact that we have June when each paper is going to be released, right? And also we have like July, right? As you can see, July is going to be like double releases because of like it's close to August, because then you have 1 month. And then we have lastly August, which is going to be this, completing the entire trial papers from last year. So this was very important for me to make sure the fact that by the time you guys write your trial exam, all the provinces are covered, right? Welcome to Prelim Free State Paper 2. As you know, the fact that this video, it's going to be in video format, and also it has the PDF version. So the PDF version is only available for membership. So I'll just give you guys a quick tutorial on how to get the PDF, right? So within the PDF, you're going to get the questions and also the answer, which is going to be basically this video in a PDF version, right? So make it a little bit easier for you guys to study, right? Because you don't need to jot down notes because of the notes already. You have them with you. So to have access to that, you just need to join the membership, and I'll just give you a quick tutorial on how to do that. So first, I'm going to show you guys on how to join the membership. Obviously, you're going to search my name, then you're going to click on my profile, then you're going to land here, right? Then you have two buttons. You have the subscribe button, right? And you also have the membership button, right? So the join button is where you join the membership. So when you click on it, right, you'll see the fact that this is going to be the membership, right? Then it tells you what you get: membership, only videos, early access, you get it, priorities, and all that, right? So now, do you see the fact that we already have exclusive content, right? So this content is strictly on the membership, right? So now when you say join membership, it's going to load, obviously. Then let me just say yes. Then it's going to load. Then when it loads, do you see the fact that now you're part of the membership, right? So when you scroll down, right, is that you're part of the membership, meaning you have access to all the members, right? So let me just go like this, right? So you can see the fact that you have everything that's related to members, meaning it's from the videos, right, to the most recent post, right? Then also now how to get the PDFs, right? So under members, you're going to see the videos. Then when you go through post, that's when you're going to see my post. You're going to see post of like public, and also when it's written to members only, you now can see it, right? As you see the fact that every time when I release a video, I do say the fact that there's a PDF. So this is the PDF for the NBT past paper, right? And also this is the PDF for the master series, right? Then this is like the normal posts, right? Then do you see the fact that this is the PDF for what? This is the PDF for paper 2, May, June. And also this is the PDF for what? For paper 1, right? Okay, so now let's go to one of the posts, right? We see the fact that this is the access. Now when you click on it, right, it's going to give you like Google Drive, because it's a Google Drive. So don't worry, it's public, right? So then when you scroll down, you'll see the fact that the PDF is within two versions, right? Is that you have the actual, it tells you that which PDF it is, right? Then you're gonna have the question paper first, right? Then after having the question paper, then you're gonna have the memo. The memo is exactly how the video is, but now it's in PDF format, right? So all of them are going to be like this, where you get what? You first get the question paper, right? Then underneath it is the memo. Hope that makes sense, right? So that is how you would get access to this PDF. So now we're going to do statistics, right? We're going to do question 1. So it says a box and whisk diagram below show the distribution of the test scores obtained for a sample of students in mathematics and science, right? So the first question says use the diagram to determine the following. So we need to find what the range of mathematics. So we know that to find the range, right? So the formula of a range, right, is what is equals to the maximum minus the minimum, right? So we're gonna go to what? We're gonna go to the mathematics. We see the fact that this is the mathematics. So we see the fact that this box, right? So we see the fact that this box here is the mathematics, right? So we need to find the maximum, right? So we see the fact that this is the maximum. So this line here, so let me just do it in a different color. Yes, right? So that's mathematics. So we see the fact that we need to find the maximum. So the maximum is this line here. So it's going to be this line here. I want it in a different color. So this line here, maybe let's do it in dotted lines. Yeah, so this line here is going to give us our maximum, and this line here is going to be our minimum, right? So if we fill it in, this is minimum. Okay, cool. So back to normal, right? So this is minimum. This is Q1. This is Q2. Then this is Q3. And this is maximum, right? So filling in the what? Filling in the Venn diagram, right? So that's how it is. So we're looking for maximum minus minimum. So now what we need to do is that from 90 to 100, we need to check how many lines are there in between. Maybe let's check where it's a little bit visible. Maybe from here, we see the fact that it's 1, 2, 3, 4. So it's 1, 2, 3, 4, 5, 6. So it's the sixth one, right? So if this is 90, so it's 1, 2, 3, 4, 5, 6. So this is going to be 2, right? So it's going to be 92, 94, 96, 98. So it's going to be 98. So it's divided into twos. So this part here is 98, right? Then we see the fact that this is going to be 10. So we see the fact that our maximum is 98. And our minimum is 10. So therefore, the range is going to be 88, right? So that's how you would find that, right? So now we need to find what? We need to find the median, right, for science. So science, I'm going to make it in green. So science is going to be green. So let's put a block there. Right, so this is going to be science. It's going to be in green. So let's put it in green, right? So the median is going to be this line here. So it's going to be the line that goes from dotted lines, right? So it's going to be this line here. This is Q2. We see that the fact that this is 60. So meaning this is going to be what? No. So let's check again, right? So this is 10, this is 20, this is 30, this is 40. So this is 50. So this is going to be what? 52. So we see that the median, which is Q2, right? So let me just do this, right? So we know the fact that this is minimum, Q1, Q2, then Q3, then this is the maximum for it, right? So this is the maximum for it. So we know the fact that Q2, right? So the medium is equals to Q2, which is going to be equals to 52, right? So it's equals to 52 here on the graph. So now they're asking for the interquartile range of science. So the interquartile range, so it's IQR is equals to Q3 minus Q1, right? So we're going to the green one. So it's going to be Q3. So it's going to be this one, right? So it's going to be this one. So let's, yep, right? So it's going to be this one. So let's do this. Green, 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 green. Yeah, so it's going to be this one, right? Minus this one. Right, so let's go back. So it's going to be this one. Right, so now let's determine it. So let me just move to solid. Right, we know the fact that this is 70. This is Q3. So we know the fact that it's 70. Then here it's 40. So it's 40. I think it's 41, 42. So this is could be 42, right? So that's going to be 42, right? Or I think it's probably 44. Yes, it's probably 44. So let's check. I think it's 44. Yeah, because I think it's like, yeah, it's 44. It's 44. Remember the fact that 42 will be somewhere here. So that's like 44, right? So we know the fact that the interquartile range, it's going to be what? It's going to be 70, right? So it's going to be 70 minus what? Minus 44. So that's going to give me 26, right? So now we're going to do 1.4. It says, which examination was easier for the students? We need to motivate. So to find which exam was easy, we need to compare the following, right? So we need to compare, right? So we are going to compare. So we're going to compare the median, right? The median, and we're going to compare the minimum, and also we're going to compare Q1, right? And what are we looking for? So if the highest, so the highest one, right, of all three, right, means that the test was easy, right? So the highest one between all of them means the fact that the test was easy. So maybe let's put this inside a block. So that's what you would compare if you had two box whisker and you want to check which one was like the easiest one in terms of text, right? So now for mathematics, so we have what? We have science and mathematics. So for science, right, we see that the median is equals to what? I think we found it. Did we find it? Yes. We found it as being 52. Then remember the fact that we need to test the minimum. So when we found the interquartile range for science, we saw the fact that that is 44. Then lastly, we need to check Q1, right? So if we go back, Q1 is going to be what? It's 44, right? So Q1 is 44. Wait. The minimum, right? The minimum for science is actually 30. So let me just do this. The minimum is actually 30. Do you see this? It's actually 30. So the minimum is actually 30. And Q1 is 44. That makes sense, right? Then now going for mathematics. Right? So let's do this. Right? So the median is equals to what? So let's go find it. So let's go to mathematics. Mathematics is this one, right? So it's going to be 44. Do you see that the median for mathematics is 44? So that's 44. Right? And we see that the minimum, so the minimum is 10. Then lastly is Q1, right? And we see the fact that Q1 for the red one, so it's 30, right? So now comparing the two, we see the fact that science, right, has a higher medium, higher minimum, and higher Q1, which makes sense. So if we look at the minimum, right, it means the fact that the, like, more or less the lowest was 30, where in maths it was 10. Do you get it? So that is why, therefore, we're gonna say science was easier. So therefore, comparing, since it has the highest, right? So therefore, science was easier compared to maths, compared to mathematics. So compared to mathematics. And you need to give reasons why, right? Since science, medium, comma, minimum, and Q1 value. Q1 value was higher than mathematics. So that's how you would answer this question, Anna. So now we're going to do 1.5, right? It says, which examination has a weak spread of score? Then we need to justify with 2 reasons, right? So with spread, we need to compare what? So a weak spread is that we need to, let's just go back to the diagram, right? So a weak spread, so let me just do this, right? So a weak spread will be looking at the minimum and the maximum, how big the spread is, right? The bigger the spread, the weaker it is. The smaller the spread, right? So cool. The bigger the spread, right? The bigger the spread, the weaker it is. But the smaller the spread, the not weak it is. So it's like stronger, right? So we're going to compare the range, because of range is from maximum minus minimum. So we can compare we're going to compare the range. And also we're going to compare the interquartile range. So again, bigger spread, weak, smaller spread, not weak. Hope that makes sense, right? So let's do that. So we're going to do what? So we're going to compare what? We're going to compare the range and the interquartile range, right? So bigger spread, highest one, so highest number, so higher, right? Higher of both range and interquartile range means weak spread, right? Means weak spread, which makes sense because I just showed you visually. So we're gonna put this inside a box. So now we're gonna find the interquartile range for science. So we know the fact that for the range for science, right, is equals to what? It's going to be equals to the maximum minus the minimum. So we see the fact that the maximum, right, is this one, which is 88, right? So it's going to be 88, right, minus 30. So it's going to be 88 minus 30. So it's going to be 88 minus 30, right? So when you say 88 minus 30, so you're going to just punch that into the calculator. So you're going to say 88 minus 30, right? It's going to give you 58, right? Then you know the fact that the interquartile range, we already found that. So we already found the interquartile range, right, of science, which is 26, right? So it's going to be 26, right? Then now we're going to go to mathematics. So we're going to go to mathematics. Right? We already calculated the range. And the range, we got it as what? It was the first question. We got it as 88. Right? Then the interquartile range. So remember, math is the grade 1, right? So it's going to be what? It's going to be 70 minus 30. So it's going to be 70 minus 30. So it's going to be 70 minus 30. So that's going to give me what? That's going to give me 40, right? So we see the fact that in both of them, when we compare, this one has a high interquartile range, has a high range and interquartile range, right? So to conclude is that mathematics has a what? Has a weak spread. Has a weaker spread. Right? Remember that we need to justify and give 2 reasons. Right? Weak spread because it's right, its range and interquartile range is higher, right, is higher than science. So that's how you would answer this question. Hope that makes sense, Anna. So now we're going to do 1.6, right? It says a learner from the science sample, right, is selected. Then we need to find, it's selected randomly. Find the probability that the learner achieved a mark that is greater than 70%, right? So we need to find the probability that the learner achieved a mark that is 70%. So how we're going to do this is that first we need to understand the percentage or the probabilities within what you call as a box whisk, right? So I'm just going to draw a random box whisk and I'm going to just label it so that you can understand how we got to the answer, right? So we know the fact that this is going to be your box, right? This is your box, right? And within the box, this is going to be, so this is going to be Q1, Q2, and this is going to be Q3. Then this extends like this, right? And this is your minimum and maximum. So we know the fact that this is going to be your minimum. We know the fact that this is Q1, this is Q2, and this is Q3, right? And this is your maximum, right? So the percentage or the probability between from here to here, it's 100%, right? So that is the percentage of like how the data is spread up, right? Or the probability in our case, right? So each quarter from minimum to maximum, so from this portion, maybe let's do it like this, right? This section here, so let me just make it small, right? Is that, do you see from this point to this point, right? There is 25%. So this whole point here, and I don't know how I'm going to do it so that it makes sense. I want to just write it properly, right? Yes. Maybe let's extend those lines, right? So let's draw dotted lines. I think that would help so that we can divide this properly. So let's do this. Yes. Right, so from here till here, right, then here, yeah, let's do this, yeah, so that we can group each section, right? So from this portion here, right, so let me just go back to being solid, right? This area here, right, this area here is 25%, so this area here is 25%. This area here is 25, 25, and 25. So what I mean is this area here right, is, so this is going to be 25%. This is another 25%. So this is another 25%. This is another 25%, right? So this is the probabilities. This is 25. This is 25, this is 25, this is 25, this is 25. That is how the data is spread out, right? This is how it's spread out. I'm saying this because I'm going to use that here, right? So I'm going to just use it here to know where does the 70% of the science lies, right? So I hope this makes sense. So now I'm going to bring back the diagram, the Venn diagram of the actual question, since we understand now we understand this. So now let's go back to the question. It says they want to know the probability, which is this, right, of the student that scored what? That scored a mark that is greater than 70%. So where does that lie, right? So we know that 70 is here, so science is going to be here. So I'm just going to draw a line. So we know the fact that this is going to be science, so this is where 70 is, right? So the student scored greater than 70, so this region here. Right? So that region is what? Remember the fact that that is what? 25%, right? So that region is what? Is 25, because everything is broken down into 25. So from minimum to Q1 is 25, from Q1 to Q2 is 25, then from Q3 to to Q2 to Q3 is 25, and from Q3 to maximum is 25. So this area here is 25, right? So the probability is equals to what? Is equals to 25. So your answer is going to be, to get greater than 70 in science is the probability. So the probability is equals to 25%. Hope that makes sense, right? So that's how you would answer this question. So now we're going to do question 2, right? So it says, let me just zoom it in, right? It says, refer to the statement below and answer the question that follows, right? So it tells us the fact that the least regression line, right, which is called the best fit, has an equation, and this is the equation. And they tell us there is one outlier, right, which is this point. And they tell us the fact that the correlation coefficient is very strong, right? Then the first one, it says, if the outlier, right, was removed, would the the correlation coefficient be stronger? Then we need to explain our answer now. So maybe let me just show you visually what happens if we have an outlier and when we don't have it, right? So let's draw two graph just to represent this, right? And this is going to be our best fit, right? So this is going to be our best fit. So this one is going to be with an outlier, and this is going to be without, right? So what happens, this is the following. We know the fact that this is okay, cool. So let me just take my highlighter. So we know the fact that this is like, right, then an outlier is somewhere here, right? Then this is the other one without it, right? So that's that, right? So that's the situation. So the best fit line, let's understand what is a best fit line, right? So the best fit line is basically a line that best fits all the data around it, right, closely by. So if we do not have the outlier, meaning the fact that the relationship it's more stronger, right? It's going to be stronger before because of the distance between this outline and this best fit is like less. We do not have this anymore. Do you see? This distance basically affects the correlation, right? So since now we're not going to have the outline, that means the fact that our correlation is going to be a little bit stronger. Hope that makes sense, right? Because we do not have this distance disturbing how the correlation is now going to behave. Hope I'm making sense, right? So this is basically what we're going to say. So the answer is going to be what? They say if the outline was removed, would the correlation be stronger? Yes. So yes. So yes. As I said, the fact that that distance, right, is going to be removed, meaning it's going to make it a little bit stronger. Yes. It would straighten So it would strengthen the correlation. So correlation coefficient. Right? So yeah, so let me just do this. So we straighten the correlation coefficient, right? So that's the answer for the first one. So question 2, it says, is the correlation coefficient closer to 1 or -1? And we need to explain, right? So how do we know whether it's going to be closer to +1 or closer to -1? It's from the equation, right? So they gave us that the equation, right, is y is equals to what? It's y is equals to 49 minus 3x. Right? So this is more or less of a linear function because this is the same as y is equals to -x, right? Plus 49. This number that is a coefficient of x is the gradient, right? So this is the gradient, right? And the gradient, right? The gradient is negative. So this is the gradient. So this is what tells us whether the coefficient is going to be negative or positive. So the gradient, right, is the one that tells us whether the correlation, right, coefficient coefficient, CICNT, right, is negative or positive. So it's going to be negative, right, or positive. So since we know the fact that ours is what? So let me just fix this. So since we know the fact that ours is negative, that means the fact that the coefficient, so therefore the answer is that the correlation coefficient, right? So the correlation coefficient is closer to negative. So it's closer to -1, right? So since m is equals to -3. Hope that makes sense, right? So that's how you would answer this question. So now we're going to do 2.3. It says, if a line of a best fit is used, would it be perfectly, very important, perfectly accurate, right? So perfectly accurate means the fact that our graph should look like this, right? So perfectly accurate means the fact that our graph should look either like this. So this is going to be your line, right? And all the data is here. That's perfectly accurate. Do you see? There's no data that's outside. Do you see the fact that in our previous one, some data is like a perfect line, right? That is perfectly accurate, right? So either like this, or this is for like a perfectly accurate for like positive, right? Or for a negative one. So this is for perfectly accurate. So this is going to be so like this. This is regarded as perfectly accurate. Our data is not like that, right? It's strong. This is strong, but it's not perfectly accurate. Hope that makes sense, right? So to answer this question is that this is perfectly accurate and our data is not like that, right? So to answer this is that is the line, if the line is specified, would it be perfectly accurate? You're going to say no, right? So your answer is going to be no. No, right? Then the correlation, so they didn't tell us that the correlation coefficient is equals to -1, right? So this is for when is like r is equals to +1, and this is when r is equals to -1, right? So is it the correlation coefficient, right? So the correlation coefficient, oh, this word, I hate it by this point. Let's copy it. Okay, duplicate it, cut it. So the correlation coefficient, right, is not equal to -1. Hope that makes sense, right? So now we're going to do 2.4. It says an individual, right? An individual predicts that x has a value of 30 and y will have a value of -45. However, his friend explains that he is extrapolating, right? And that his result is inaccurate, right? Explain what the friend is referring to. So what we need to explain in general sense is that we need to explain what this word means, extrapolating, right? So I'm just going to give you the definition of extrapolation, and I'm going to just explain what it means in essence, right? Why the friend is saying the fact that that can't be like accurate, right? So extrapolating, right? So extrapolation, right? Extrapolation means making prediction. So making predictions, right? Making predictions for x values, right? So for x values that falls right outside the range of observed, so observed data, right? Data used to create the model. So the model basically is the linear regression line. So the model is the regression line. I hope I spelled regression right. So the model is the regression line, right? So that's what it is. So now let's see it visually. What does extrapolation means, right? Is that, let's say you have your data, which is, this is going to be your data, right? And you have the best fit line, and that's your best fit line, right? And within the best fit line, we see the fact that within your data, obviously this is going to continue. So we know the fact that this is like going to be up. Okay, wait. Right. So this is going to continue, right? So let's say the fact that within your data, then your data is divided into areas where your data falls, right? So this is going to be the area. So let me just create maybe a dotted line. And we're going to just divide it by like a red line. So let's divide it with the red line, right? So let's say the fact that we divide the area. So this is the entire area. So this is the entire area that we can predict. And I'm just making it. Obviously, it's going to be more than that, right? So this is going to be like maybe the entire area that you can predict, right? Right? So this part here, do you see? This is the entire way you can like predict, right? So that is that, right? So we have that. So we have that, right? Then within that is that we see the fact that there is part of the area that we can predict that are going to be like more or less like safe zones, right? Which is known as interpretability. in my head pronouncing that word, right? So is that there's this area, right? Then there's going to be an area where it's safe, right? So when area is safe, this is going to be the area where the data more or less lies on, right? So that area is going to be the safe zone, right? Then there's going to be the area that is not the safe zone, which is the risky part, which is the extra what you call this, the extra thing that we've been talking about. It just ran away, the word just ran away, right? So basically it says the fact that if I predict, right, if I predict from here, right, it's more or less safe. Predicting from here, right, it's okay, cool. So predicting from here is more or less safe, right? But predicting from here is not safe. So that's what it says, right? So maybe let's just highlight, right, the area. So we see the fact that the safe area, this safe area. So this will be regarded as safe. Okay, cool. So this area here where the data is the safe zone. So this is safe, right? So this is the safe zone, right? So this is the safe, and this is the risky part. Because you see the fact that yes, you can still predict, right? But it's more risky. So this section here, let me move to solid, right? This section here that is risky, more risky, is known as the extra, Hope that makes sense, right? Is that yes, you can predict on here, but there isn't data there, so it's more risky. But the part that you can predict, right, is safe. So this is risky, and this is safe, right? And the side that is safe is known as the intra. So let me just get it, intra. So that is basically what it means. So hope that makes sense, honey. So yeah. So now we're going to do analytical geometry, right? So the question says, question 3, in the diagram below, PQR is a triangle with vertices. They give you P, Q, and R, right? So they give you all 3 coordinates, right? So the first one says calculate the length of Q. So we need to calculate the length of QR. So this is what we're looking for, right? So that's what we're looking for. So we know the fact that we're looking for QR. So we're looking for Q. All right. So to find QR, we're going to be using the distance formula, right? So using the distance formula, so it's going to be x of Q minus x of R all squared, right? All squared plus then y of Q, right? And it's going to be minus y of R, right? So this whole thing is going to be inside the square root like this, right? So therefore, this is going to be the square root. Then this is x of Q, right? X of Q is negative 3. So it's going to be minus 3, right? Then it's going to be minus 5 all squared plus, it's going to be 3. Then it's going to be minus 3, right? So minus 3 all squared, right? So sorry, this is all squared, right? So now clean it up. It's going to be the same as square root. And here we're going to have what? We're going to have 64, right? Then this is going to be 36, right? So all square root. So when you punch this into the calculator, you're going to get the fact that this is going to give you 100. Sorry, it's going to give you 10 units. Right? So QR is going to be equals to 10 units. Hope that makes sense. So that's how you would solve this question. So now what we're going to do is that we're going to do 3.2. It says determine M, and M is the midpoint between Q and R. So using the midpoint, right? So midpoint, which is going to be M, is equals to, then the midpoint, remember the fact that the midpoint is between Q and R. So that is going to be XQ plus X of R divided by 2, and this is going to be YQ plus yr divided by 2, right? So now we're going to substitute. So when we substitute, we're going to have what? We're going to have negative 3 plus 5 divided by 2. And this side, we're going to have 3 plus negative 3, right, divided by 2, right? So this is going to be m. The coordinate of m is going to be what? So at the top, it's going to be 2 divided by 2 is 2. Then this is going to be 0 divided by 2. So cleaning it up, m is going to be, the coordinate of m is going to be 1 is 2, 0. So now we're going to do 3.3. It says we need to determine the equation of the line passing through the point P and M, right? So we know the fact that, let me put the coordinate of P. So we know the coordinate of P is negative 5. So it's going to be negative 5 is to what? So it's going to be negative 5 is to negative 3. It's going to be negative 5 is to negative 3. And M is going to be 1 is to 0, right? So to find the equation, it's going to be y is equals to mx plus c. So first, let's find the gradient. So we know that the gradient is going to be equals to yp minus ym divided by xp minus xm, right? Just to make sure is that, remember the fact that if we're going to start with p, we need to also start with p at x, right? Remember the fact that consistency matters, right? So let's substitute. So it's going to be m is equals to, so it's going to be yp, it's going to be negative 3, right? Minus 1, minus 0, divided by xp, it's going to be minus 5, right? And it's going to be minus, so it's going to be minus 1, right? So let's clean it up, right? So let's just make sure, right? Yeah, so this is y, so this is y, and this is x, and this is x, okay, right? So now let's clean it up. So it's going to be m is equals to, so it's going to be negative 3 divided by what? Divided by negative 6, right? So now we know that our m is going to be equals to what? It's going to be equals to positive a half. So we know that our m for our gradient is going to be equals to positive a half, right? So now, knowing that m is equals to positive and a half, let's update it. So let's update y is equals to mx plus c, right? So we know that y is going to be equals to a half now, x plus c, right? So we're going to substitute either coordinate between these two, right, to find what? To find our c. So I'm going to substitute the one that they gave us, which is p, right? So it's going to be p, it's going to be negative 5 is to what? Is to negative 3, right? So now it's going to be what? It's going to be negative 3 is equals to 1 over 2. Then it's going to be negative 5 plus c, right? So now with that said, is that let's clean it up a little bit further, right? So this is going to be the same as negative 3 is equals to negative 5 over 2 plus c. So it's going to be negative 3. Take this one. So it's going to be 5 over 2 is equals to c. Punch this into the calculator. You're going to find that your c, so you're going to find that your c is actually equals to what? It's actually equals to negative a half, right? So we're going to find that this actually equals to negative a half. So therefore, the equation is going to be y is equals to a half x, right, minus 1 over 2. So now we're going to do 3.4, right? It says determine the equation of the circle, right, that has a diameter of QR. So we're going to have a circle. So we know the fact that we have a circle. Sorry. So we have a circle. So let's, yes, so we have a circle, right? So we have a circle, right? And let's make it red. Doesn't matter. So let's make it red, right? So within that circle is that circle, right, has a center here. So we know that a circle has a center. So a circle has a center, which is here, right? So we know the fact that they gave us the diameter. So the diameter of the circle, it goes through here like this, right? And the diameter is QR, right? But remember the fact that we found the midpoint. So meaning the midpoint is going to be the center. So we have the midpoint. So the midpoint is going to be the center, right? And our center, we found it as what? As 1:0. So we found our center as being 1:0. So it's going to be 1:0, right? So now we know the relationship between the diameter and the center, right? So we know that the radius, because in our formula, so before we do this, we know that the formula of the circle is x, right, minus a, so x minus a all squared plus y minus b, so y plus b, or yeah, is equals to the radius, right? So we already know what is a and b, right, because of this, right? So we know the fact that our a from the center, we know the fact that m is the center, right? So we know the fact that our a from here is going to be opposite the sign. Since this is positive, this is going to be -1, and our b is going to be equals to 0, right? So updating it is going to be x, right, minus 1 all squared plus this is going to be y plus 0 all squared, right? It's equals to r, right? So it's going to be equals to r squared. Hope that makes sense, right? So that's what we have. So now to complete the equation is that we need this r, right? But let's clean this up first. It's going to be x minus 1 all squared plus y squared is equals to r squared, right? So we need to find r. But we know that we know that the diameter, right? But we know that the radius, yes. So we know that the radius is equals to a half of the diameter, right? So we already know that the diameter, right, which is QR. Remember the fact that earlier on we calculated it, right? So we know the fact that QR is equals to 10, right? So we know that QR is equals to 10. So therefore, our radius is basically equals to a half of 10, right? So therefore, R is equals to 5, right? So now updating it, it's going to be the equation of the circle. So the equation of the circle, so the equation, right, of the circle is basically equals to x minus 1, right? So it's going to be x minus 1. So it's going to be x minus 1 all squared plus y squared is equals to our r as 5 all squared. So now let's clean that up. This is going to be x minus 1 all squared plus y squared is equals to 25. So now we're going to do 3.5, right? So it says, does the point P lie inside or outside the circle, which is the circle that we found here, right? And we need to motivate our answers with relevant calculations, right? So now this is the general rule, right? This is the general rule. So within the general rule is that we need to find the distance between the center and the given point. So our center, we know the fact that with us is that the center, right, is what? It's m. And m, we already calculated it as 1:0. So the center of the circle, right? And our given point, right? Our given point. So this is the given point. Right? So the given point is what? It's P. And let's go back and check what P is. So we see that P is -5 is to -3. So it's going to be -5 is to -3. Hope that makes sense, right? So now is that we need to find the distance between them. So let's find the distance. So we're looking for MP, right? So MP is going to be the square root. Then this is going to be x of m minus x of what? X of p all squared plus y of m minus y of p all squared, right? So this is going to be inside this. Same applies with the gradient, is that here consistency. If we're going to start with m, we need to start with m here, right? So this is going to be the same as the square root. Then this is going to be 1 minus -5 all squared plus this is going to be 0 minus -3 all squared, right? So this is going to be the square root, and this is going to be basically the same as what? This is the same as 1 plus 5 all squared plus, then this is going to be 3 all squared, right? So that's what we're going to have, right? So from there is that we know the fact that this is going to be what? This is going to be the same as 6 squared plus 3 squared, right? So what is 6 squared, right? So we need to find 6 squared. So we know the fact that 6 squared is going to give me what? It's going to give me 36. So it's going to be square root of 36 plus 9, right? And this is going to be equals to what? This is going to be equals to 45, right? So 45, this is going to give me 6, 7, right? So this is going to be this. So let me just do this. So we know that the distance between which this distance is the same as d, right? Because when we compare it, we're going to say the distance formula, which is d, right? So when it's inside, the distance is going to be what? It's going to be less than the radius. So then that's going to be inside. If the distance and the radius are equal, then they are touching on the circumference. And if the distance is the biggest one and the radius is the smallest one, meaning it lies outside. So we know that the distance is going to be what? D is going to be equals to 6, 7, right? Then we need to find our radius. We know that our radius in this case is going to be what? Our radius, remember the fact that it's 5, right? So our radius of the circle is 5. So we see the fact that it's 5, right? So we see the fact that our distance is the one that's greater than what? That is greater than our radius, because this one is bigger than this one. Hope that makes sense, right? So knowing that is that this is going to be this one, right? So meaning that the graph lies outside. So meaning the point P, right? So since this is the case, therefore point P lies outside the circle. So now we're going to do 3.6, right? It says we need to determine the coordinate of S if PQRS is a parallelogram, and they tell us the fact that S lies in the first quadrant. So S needs to be here, right? So now let's draw the parallelogram, right? So we see the fact that this is point P. So P, right? Q, right? R, right? Then S. So S, remember the fact that it lies here in the first quadrant, so it needs to be here. So we're going to have that. So let's connect it. So this is the parallelogram. So this is going to be like this, right? And this is going to be this one here. Right, then this. Okay, cool. So let's do this. Let's do this, right? So we know the fact that this is P. So it's like this, and this connects here, and this connects here, and finally this connects here, right? So connects here. Right? So we know the fact that this is a parallelogram, and this is going to be S. Right? So that's our parallelogram, right? So we have one property of the parallelogram, the fact that the diagonals, right? So the diagonals, so this diagonal, we know the fact that this is a diagonal, and this diagonal, right, is that this side is going to be equals to this side, and this side is going to be in this equals to this side, and the midpoint, which is, we know the fact that it's M, right? So this is the property. Let me just, because we've done a similar question with this, right? So one of the property, this is the properties, and I'm just going to copy and paste it. So I'm going to just copy it and paste it. We're going to use the same property, which is this property, right? I'm just going to paste it here, right? So we're going to use the properties of the diagonal, the fact that the diagonal bisect each other, which is what we did, right? Since we already know that this is 1 is to 0, right? Is that we're going to use the midpoint theorem, right? So we're going to use the midpoint theorem since we have this point here and we have this point to find this S. Hope that makes sense. So we're going to use the midpoint theorem, finding the relationship, finding the midpoint of PS, but we already have the midpoint, so we can find S. Very simple. Hope that makes sense, right? So now what we're going to do is that we're going to use the midpoint theorem. So using the midpoint, right? The midpoint M, which is 1 is to 0, to find S. because of this diagonal property, right? So we're gonna name S as being as XS and YS, right? So that's how we're gonna name it. So we know that the midpoint, we know that M, which is the midpoint, is equals to what? Is equals to, we're gonna use this line, right? Which is gonna be PS, right? So we know the fact that this is gonna be X of P plus X of S, right? And this is going to be divided by 2. And this is going to be Y of P plus Y of S. It's going to be divided by 2, right? So now we already know what the midpoint is 1 is to 0. So we know the fact that this 1 is to 0 is equals to, then X of P, right, is going to be equals to what? It's going to be equals to -5. Then this is going to be X of S, because that's what we're looking for. And this is going to be divided by 2. And this is going to be Y of P, which is going to be -3. Plus YS is going to be divided by 2, right? So now what we're going to do is that we're going to equate this, right, with the X. So this, right? And we're going to equate this with this. So to solve that, right? So now we're going to do that. So we know the fact that 1 is going to be equals to -5 plus X of S divided by 2. So let's solve. So it's going to be 1 multiplied by 2 is equals to -5 plus X of S. So therefore, this is going to be 2, right, plus 5 is equals to X of S. So X of S is basically equals to 7, right? Then now we're going to solve for the Y. So it's going to be 0 is equals to -3 plus YS divided by 2. So it's going to be 0 multiplied by 2 is equals to -3 plus YS. So it's going to be 0, right? Then it's going to be equals to -3 plus YS. So therefore, YS is basically equals to +3. So we know that the coordinate of S, right, is going to be 7 is to 3. So that's the coordinate of it. So now we're going to do question 3.7. It says we need to calculate the size of QPR, right? So QPR, meaning we're looking for what? We're looking for this angle. So we're looking for this angle here, right? So that's what we're looking for, right? So we're looking for this angle here, right? So what do we see? We see the fact that do you see the fact that here, right, the line that goes from here to here, right? Since they share the point P and point R share the same Y coordinate, right? Is that this line, right, it goes like straight, meaning this line is now parallel to this line, right? So because they share the same Y coordinate, right, is that the line that passes through here is going to be parallel to this line. Hope that makes sense, because of they share the same Y coordinate, right? So we know the fact that now these two lines are parallel to each other. So we know the fact that this line here is going to be parallel to that line. If those two are parallel, right, is that we see the fact that if this line is parallel to this line, to the, very important, is parallel to the x-axis, right? Because of, again, I'm going to emphasize it, because they share the same Y coordinate, is that this is going to create an F, right? Meaning now that this angle is equals to this angle. So meaning this is going to be also theta. Why this is nice is that I can find this angle here, right? I can find this angle here using the tan theta is equals to the gradient. I can find it, and I already have the gradient of here. And if I find this theta by default, I'm finding this. Hope that makes sense, right? So now let's write everything that I just said down, right? So number 1 is that since point P and R share the same Y coordinate, that means that PR is parallel to what? Is parallel to the x-axis. So that's the first part, right? So since now they're parallel, so number 2, we know the fact that now angle theta is going to be equals to the angle that they want, which is going to be QPR. So it's going to be QPR. And the reason for that is going to be corresponding angles. Right? So we know that, right? So now we can find our theta. So number 3, we can find theta, right? So find theta. So we know that theta, tan theta is equals to, right? So tan theta is going to be equals to your gradient, right? So going back, right, is that the gradient of QP, right? So the gradient of PQ, so it's going to be the gradient of what? Of QP. Did we find the gradient of QP? Let me just check. I don't think we did. Okay, let me just go up. Okay, no, we didn't. We didn't find. So we need to find the gradient of what? So we need to find M first. So we need to find the gradient of M, which is M of QP. So QP, right? So we see the fact that it's going to be what? It's going to be Y. So YQ minus YP divided by what? Divided by XQ minus XP, right? So we know that Q is what? So let's go up. We know Q is negative 3 is to 3. So it's going to be negative 3 is to 3. And our P, so our P is what? Our P is negative 5 is to 3. So it's going to be negative 5 is to 3, right? So let's confirm. Negative 5 is to negative 3. Yes, right? So now finding the gradient is going to be what? So the gradient of QP, right? So we know that the gradient of QP is going to be negative. It's going to be 3 minus what? Minus 3. Then this is going to be divided by XQ, which is going to be negative 3 minus 5, right? So this is going to be the same as 3 plus 3 divided by negative 3 plus 5. So this is the same as, it's going to be 6 divided by what? By 2. So this is going to be the same as 3, right? So our gradient is going to be positive 3. So, right? So now we know the fact that our gradient is going to be positive 3. So now finding theta, right? So we know the fact that therefore tan theta of gradient of what? Of QP is equals to tan theta of 3, right? So therefore theta is equals to arctan of 3. Punch this into the calculator. Theta is going to be equals to 71,57, right? So therefore the angle that they want, which is QP, right, R, is basically equals to also 71,57, right? And that's how you would solve this question. So now we're going to do question 4, right? It says in the diagram B, right, is negative 1 and 1. So they didn't write it down. So we know that B is negative 1 is to 1, which is the center of the circle. Then they tell us the fact that CA is the tangent. So we see the fact that CA, right, is the tangent. The entire thing, actually, CR is the tangent to what you call this is the tangent to the circle at point A. So we see that. Then they tell us the fact that C is negative 1 in 26. Then they tell us the fact that this angle here and this angle here are equals to each other and they theta. And they tell us the fact that CA is equals to 20. So 20 units, right? So this is the information that they give us, right? So now the first question says, calculate the following: the length of the radius of the circle, right? We see the fact that the radius is this. It's a point from center going to where? Going to the circumference, right? So we see that. And we see the fact that since this is a tangent, right? So since this is a tangent line, right? That means the fact that this is 90 degrees, So we know the fact that this is 90 degrees, right? So we see the fact that this is 90 degrees, right? And we see the fact that this is the only missing part, right? So since this is the only missing part, I'm just going to highlight this triangle. Is that using this right angle triangle, right? Is that we can find this red part. How we can find it is that we already have what? We already have this two. We have this coordinate here and this coordinate. So I can first find the distance. After finding the distance, meaning this is going to be the only missing side. So I'm going to use theorem of Pythagoras. Hope that makes sense, right? So now we know the fact that using the thingy, the triangle, is that we're going to basically use theorem of Pythagoras to solve this, right? So first we need to find so we're going to find C. Okay, yeah, we're going to find that CA. So we're going to find CB, sorry. We're going to find CB, right? So we know the fact that C is what? The coordinate of C is -1 and 26. And B, they gave us it's -1 and 1, right? So that's that, right? So we see the fact that, just to make it a little bit shorter, we see the fact that this x coordinate is the same, right? So finding this distance here is basically finding the difference between these two, because these two are going to cancel out, right? So finding the distance of CB, right, is the same as what? Since we have the same y, right, it's the same as finding this and this only, finding y. So let's just do it, and I'll just show you using the distance formula. You'll see the fact that it's going to cancel. So next time you know the fact that if you have the same x, you don't need to put it down in the formula. So now we know the fact that it's going to be xc minus xb all squared plus yc minus yb all squared, right? So this is the same as what? The square root. And this is going to be -1, right? Minus 1 all squared. Then this is going to be what? This is going to be 26 minus 1 all squared, right? So this is going to give me 0, as I said. So this is going to be 0 all squared. And this is going to give me what? 25 all squared, right? So now this is the same as having what? The square root of 25 all squared. So our CB is going to be basically 25. So we see that CB is going to be equals to 25. So let me just complete the square roots here, right? So we're going to have that, right? So we know that CB is equals to that. So now we know the fact that this is 25, right? Since this is the hypotenuse, right? So it's going to be this side plus this two sides, right? Using theorem of Pythagoras. So we know the fact that it's going to be what? It's going to be CB. CB, so finding the radius, right? So we know the fact that CP squared is going to be equals to what? It's going to be equals to AB, which is the radius. So it's going to be AB, right? Which is the radius. So the radius, which is going to be AB, which is going to be the same as R, right? So it's going to be AB, right? AB plus CA. So it's going to be plus CA squared, right? So let's substitute. We know the fact that this is 25 squared, right? And this is going to be equals to what? R squared. And this is going to be 20 squared, right? So it's going to be 20 squared, all right? So now this is the same as 25 squared minus 20 squared is equals to R squared, right? So now we're going to clean it up, right? We're going to clean it up. So when we clean it up, this is the same as what? This is the same as the square root of 25 squared minus 20 squared, right, is equals to square root of R squared, right? So therefore, R is equals to, punch this into the calculator. You're going to see that your R is going to be equals to what? Your R is going to be 15. You don't need to say plus or minus, because radius, the distance of radius is always going to be positive. So your r is going to be equals to 15. So that's how you solve your. So now we're going to do 4.2, right? It says determine the equation of the circle. The equation of a circle is going to be x, right, plus a all squared plus y plus b all squared, right? And this is going to be equals to what? To r squared. So we need our a, right? So our a and b, so comes from the center. So the center, right, gives us our a and b, right? Then r, obviously we know the fact that that's the radius. So now we know the fact that our center, right, in our equation is what? Is b, right? So we know the fact that the center is b, right? And our center is what? Is -1. So our center is b, right? Which is going to be -1 is to 1, right? So it's going to be -1 is to 1. So it's going to be -1 is to 1. And we know that our r in our case is what? Is 15 because we solved it here, right? Hope that makes sense. So now with that said is that we know the fact that our a, so our a is always opposite the sign, right? Since here is what? Since here is negative, meaning our a is going to be positive. And since here b, and also b is opposite the sign. Since b here is what? Is positive, therefore b here is going to be negative. So now let's substitute, right? It's going to be what? Our equation of the center of the circle is going to be x, right, plus 1 all squared plus y minus 1 all squared is equals to 15 squared, right? So let's clean it up. It's going to be x plus 1 all squared plus y minus 1 all squared, right, is equals to what? Is equals to 225. So this is going to be the equation of the circle, right? So that's how you would find the equation of the. So now we're going to do 4.3, right? So it says we need to find the equation of the tangent CR, right? So the equation of CR, so we're looking for this equation in red. So it's going to be this one, right? So now what do we know about the relationship between the tangent and the radius, right? We know the fact that this is 90 degrees, right? So we know the fact that this is going to be 90 degrees, right? Then what else do we know? We know the fact that this, right, is equals to this, right? And it's going to come into play. We already calculate, we know the fact that this is 20. This is what it's given. So we know the fact that that side is 20, right? And we know that this side is what? Is 25. And we also know the fact that this CP, which is the radius, right? This AP, right? Do you remember that AP, which is, what you call this? The AP, which is the radius, the AP is equals to 15, right? So we know the fact that this is 15. The reason why is that I'm going to use this triangle, right? This triangle that I'm going to highlight in red, right? To basically find what? To basically find the gradient, right? Because we know the fact that if this gradient, right, if this angle is equals to this angle, is that I can find this angle because of this is a right angle triangle using trig ratios, right? Then to find the gradient of this line, right? To find the gradient of this line is that I'm going to use this relationship and use tan theta, right? So using the yellow triangle, right? Using the yellow triangle. So since we know the following, right? We know the fact that these two are equal, right? So meaning if I find this angle, it's going to be easy for me to find the gradient of this line. Hope that makes sense, right? Then we can find the equation of the tangent. Hope I haven't confused anyone, right? So now is that we know the fact that what? We know the fact that we can find tan theta. So we know the fact that, the equation, so the equation of line CR, right? So CR is equals to what? It's basically Y is equals to MX plus C, right? But we know the fact that to find the gradient, right? We know that to find the gradient of CR, right? Of CR. So gradient of CR. So this is going to be CR, right? Is the same as what? As tan theta. So now we know this relationship, right? So from the diagram, we know the fact that, so from the yellow triangle is right, we can find tan theta. So from the yellow triangle, right, we can find tan theta. So let's go back, right? So we know that tan theta is going to be what? It's going to be opposite over what? Over adjacent, right? So it's going to be 20 divided by 15, right? So it's going to be, we know that tan theta, it's going to be what? It's going to be 20 over 15. So it's going to be the same as 20 over 15, right? So now let's like just simplify this. So we know that tan theta is equals to what? Is equals to 4 over 3. But we know this relationship, right? We know the fact that tan theta is equals to the actual gradient, right? So the gradient of CR. So therefore, we know that the gradient of CR is also equals to 4 over 3. Hope that makes sense, right? So now we have the gradient of CR. So now updating it. So updating. Spelling, updating y, right? So it's going to be y is going to be equals to what? It's going to be equals to 4 over 3 x plus c, right? So now we're going to substitute. So remember the fact that we're looking for this equation of this line. We only have this coordinate, so we're going to substitute c to solve for c, right? So we're going to substitute c, the coordinate c, which is the coordinate of c is going to be what? It is negative 1, 21, negative 1, 26, right? So this is the same as 26 is equals to 4 over 3, and it's going to be negative 1 plus c. So it's going to be 26 is equals to negative 4 over 3 plus c. So it's going to be 20. So it's going to be 26, right? So it's going to be 26, right, plus 4 over 3 is equals to c, right? So therefore, when you punch this into the calculator, you're going to find that your c is going to be equals to what? So your c is going to be equals to 82 divided by 3, right? So therefore, the equation is going to be y is equals to 4 over 3 x plus 82 divided by 3. So now they want us to determine the equation of the radius AB. Let's go up, right? So we see the fact that the relationship between AB and also the one that we have, right, is that they're perpendicular. So we know the fact that since AB is perpendicular to CR, we're going to use that relationship of perpendicular to find the equation of the line AB of the radius, right? So that's what we're going to be doing. So let's go here, right? We know the fact that the gradient, right, of AB multiplied by the gradient of what? Of the tangent with the CR, right? CR is equals to negative 1. And the reason for this is because of AB is perpendicular to CR, right? Cos 10 perpendicular to radius, right? So since we know the fact that now we're looking for the gradient of AB multiplied by the gradient of CR, we know that CR is 4 over 3, so it's going to be 4 over 3, right, is equals to negative 1. So now it's going to be the gradient of AB is equals to negative 1, right, divided by 4 over 3. Punch this into the calculator. We see that the gradient of AB, right, is equals to what? It's equals to negative 3 over 4, right? So we have the gradient of what? Of AB, right? So we're looking for the equation. So it's going to be y is equals to m of AB, because that's the radius, x plus c, right? So now let's update it. It's going to be y is equals to negative 3 over 4 x plus c, right? So now we're going to substitute what? We're going to substitute either a. We do not have a, so we're not going to substitute a. So we're not going to substitute a, we're going to substitute b, which is going to be what? Remember that b is what? Is negative 1 is to 1, right? So we're going to substitute b, right, to solve for what? To solve for c. So we're going to substitute b which is -1 is 2, 1, 2. Solve for C. So this is the same as what? This is going to be the same as 1 is equals to -3 over 4, and this is going to be -1 plus C, right? So this is going to be 1 is equals to what? Is equals to 3 over 4 plus C. So this is going to be 1 minus 3 over 4 is equals to C, right? So now when you punch this into the calculator, -1, like 1 minus 3 over 4, you're going to get the fact that your C is basically equals to 1 over 4, right? So you're going to get the fact that it's equals to 1 over 4. So now your C, so now your updated equation of AB is going to be Y is equals to -3 over 4, right? X plus 1 over 4. So that's going to be your equation of the radius AB. So now we're going to do 4.5, right? It says the coordinate of A. Let's go back and see what is the coordinate of A, right? See, we see the fact that the coordinate of A is here. This is an intersection between this line, CR, and this line, right? And this line AB. And we have both those equations, right? So is the intersection between what? So is the intersection between what? So it's basically the intersection between line. So the line what? So let's go back. The intersection between the line CR. Yes, CR. And AB. So we need to equate them, right? So we know the fact that CR going back is equals to this one. So it's going to be basically 4 over. So it's going to be 4 over. So it's going to be 4 over 3, right? X. Right, so it's going to be 4 over 3x plus, so it's going to be plus 82 divided by what? Divided by 3 is equals to this one, which is going to be -3, right? Divided by 4x plus 1 over 4, right? So we're going to basically be solving for x and y, right? So solving for x first. So solving for x. So now let's change this up. So it's going to be 4 over 3 x. Bring the one with the x here. So it's going to be plus 3 over 4 x, right? It's going to be equals to what? It's going to be equals to 1 over 4, right? And it's going to be minus 82 divided by 3. So if I say 4 over 3x plus 3 over 4x, I'm going to get the fact that this is going to be 25. So this is going to be 25, right? Divided by 12x, right? And this is going to be equals to, when I say 1, so when I say 1 minus 82 divided by 82 divided by what? 82 divided by 3, right? Is that I'm going to get, I'm just going to write it the way it is. So I'm just going to get, say 1, right? So this is going to be 1 divided by 4 minus 82 divided by 3. I'm just going to leave it like this, right? Because if I punch that into the calculator, I'm going to get decimals. I do not want decimals, right? So therefore, x is going to be equals to, divide throughout this whole thing. So this is going to be this 1 over 4 minus 82 divided by 3, right? Divided. Remember the fact that on this side is multiplying, meaning when it goes to the other side, it's going to be a division. So it's going to be divided by 25 divided by 12, right? So now x, when you punch this into the calculator, when you punch this whole thing into the calculator, you're going to find that your x is going to be minus 13, right? So it's going to be minus 13. But remember the fact that we're looking for the coordinate of A. So now we're going to substitute x equals to negative 13 in either or. So you can substitute it here, right, or here. So I'm going to substitute it to in either or, right? So substituting it in maybe y. So y, substituting in y is equals to, let's pick either one of them. So I'm going to pick the one with the negative. So it's going to be negative 3 over x, 3 over 4, x, right, plus 1 over 4, right? So you're going to get y is equals to negative 3 over 4, right? And this is going to be negative 13. Then it's going to be plus 1 over 4. So it's going to be 1 over 4. Right? So therefore, y is going to be equals to, punch that into the calculator. You're going to get it as being 10, right? So now the coordinate of A is going to be what? Negative 13. So it's going to be negative 13 is to 10. So we're going to do trigonometry and we're going to do the first question. It says solve, right, 5.1.1. If tan theta is equals to 8 over 6 and theta is between what? It's between 0 and 90 degrees. Show that tan sine open bracket theta plus x is equals to what? Is equals to 6x squared plus what? Plus 8 cos x, right? So the first thing that we need to do is that we need to basically draw the Cartesian using this information. So that's what we're going to do. So we're going to draw a Cartesian. So let's do that. So we're going to draw a Cartesian plane just like that, right? So they tell us the fact that the first information, right, is that theta is equals to 8 over 6. So we need to check where 10 is positive because of 8 over 6 is positive. So we see the fact that this is the what? This is all. So let's just do that. This is all students take coffee, right? So 10 is positive in the first and the, so it's positive in the first and the third quadrant, right? But when drawing the triangle is that we need to only have it in 1. So we see the fact that now we have it in 2. So we have another set of information that theta, right? Our angle is between 0 and 90 degrees. So we know the fact that this is 0 degrees, this is 90 degrees, this is 180 degrees, and this is 270. So this is going to be 270, and this is 360, right? So that means the fact that since it's between what? It's between 0 and 90, so meaning it's in this quadrant. So it's going to be here. So we see the fact that our triangle is going to be here. So it's going to be this triangle like this, right? Very important, the triangle, this line, right, always touches the x-axis, not the y, the x-axis. Hope that makes sense, right? So this is going to be a right angle triangle, right? Then remember the fact that our 10 is what? Our 10 theta is equals to what? To 8 over 6. So theta is going to be here. Always theta is going to be the angle, right? Between what? So it's going to be the angle between this line and the x-axis. So that's going to be the case always, right? So we see the fact that that is the angle. So we know the fact that 10 is what? Is opposite, right, over adjacent. So opposite is going to be 8 here, then adjacent is going to be 6 here. Hope that makes sense. So here is going to be 8, right? And this is going to be 6, right? So that's that, and this is going to be R, right? So one important thing is that, do you see the fact that this one, right, always going to represent X? This one, because of its parallel to the y-axis, is going to represent Y, and this is going to be R. Reason I'm saying this is because when we're finding our R, X or Y, depending on the question, is that you need to know who is X, who is Y, and who is R. Hope that makes sense, right? So this is going to be this. So now we need to complete this diagram. So meaning we need to look for R, right? So let's do that. We see the fact that R, this is Pythagoras, like using Pythagoras because it's the right angle. So it's going to be R squared is equals to X squared plus Y squared, right? So we're looking for R squared in our case, and our X squared is 6, right? So it's going to be 6 squared. Then our Y is going to be 8 squared, right? So that's that. Then it's going to be R squared is equals to what? What you call it, 6 squared is going to be 36 plus 8 squared is going to be 64. Therefore, R squared is going to be equals to what? It's going to be 100, right? Square root both sides. So it's going to be R squared is equals to square root of 100. Very important. You don't need to say plus or minus when you're solving for R, because of R is always going to be positive. So it's going to be R is equals to 10. So we see the fact that our R here is equals to 10. So our diagram is complete now, right? So now solving the question, which is going to be what? We're looking for 10 sine. So we're proving, right? Our goal is we're proving that 10 sine, right? So 10 sine, then it's going to be what? It's going to be theta plus x, right, is equals to what? It's equals to 6 sine x, right, plus 8 cos x. So we're proving this, right? So what we're going to do is that this is going to be your left hand side. So this is your left hand side and this is your right hand side, right? So we're trying to prove that the left hand side is equals to the right hand side. So I'm going to take the left hand side and try to prove the fact that it's exactly like this, right? So taking the left hand side, which is equals to 10 sine, that's going to be theta plus x, right? So now using the identity, right, this identity, which is going to be a plus b, right, is equals to sine a cos b, right, plus then it's going to be what? It's going to be cos a, right? Then this is going to be sine b. So using this identity, I'm going to put it down inside here in red, right? Using the identity is that we're going to apply this identity here, because what do we see? We see that theta is a and sine is x is b, right? So using this identity, we know the fact that 10 sine theta plus x is equals to 10, then put everything into a square bracket, right, which is going to be applying the identity. We know the fact that a is theta, so it's going to be sine theta, right, cos, then x is b, right? It's going to be cos x, then it's going to be plus cos theta, right, then it's going to be sine x, square bracket, right? So now we have this, then we're going to basically clean it up, right, distributing the 10. So no, let's not distribute the 10 yet, right, but let's basically apply this. Remember the fact that we already have this diagram, right? We have this diagram and it's in terms of theta, right? So we're going to find sine theta and cos theta. So that's what we're going to do. So it's going to be 10. Then we see that sine theta is what? It's opposite, right, over hypotenuse. So it's going to be 8 divided by 10. So it's going to be 8 divided by 10. So it's going to be 8 divided by 10. And it's going to be cos x, right? And it's going to be plus. We see the fact that cos theta is going to be adjacent over hypotenuse. So it's going to be 6 divided by 10. So it's going to be what? It's going to be 6 divided by 10. And this is going to be sine theta, right? Then now we're going to distribute the 10, right? So it's going to be 10 multiplied by 8 divided by 10, right? Cos x plus 10 multiplied by 6 divided by 10, right? Sine x, right? Clean that up. So when we clean that up, we know the fact that this is going to give me just 8 because the 10 are going to cancel out. So it's the same as 8 cos x, right? And here it's going to give me just 6 because the 10 are going to cancel out. So it's going to be plus 6 sine x, right? So we see the fact that we're trying to prove what? Remember the fact that our goal is to prove this, and we see the fact that this 2 is the same thing. It's just written in a different way. So let me just write it properly. Since it's addition, I can swap the position. So there's going to be 6 sine x plus 8 cos x, right? So that is exactly the right hand side. So this is equals to the right hand side, and you're basically done with this question. Hope that made sense. Amen. So now we're going to do 5.1.2. It says hence, right? Hence means the fact that use your previous question to solve the next one, right? Hence solve the following. So we have this, right? So what I'm going to do is that I'm going to take what we wanted to prove, right? So remember the fact that we were proving this, right? So the hence comes from this. So let me just duplicate it and cut it, right? This is our hence. So this, right? So I'm going to say this is hence, right? So this is hence. So let me just paste it, right? So let me paste it, and I'm going to put it inside a block. So we know the fact that this is hens. So this is hens. This is our hens, right? This is what hens means, right? So this is hens, right? What do we see? We see the fact that this whole thing is exactly equals to this, meaning this two can be equals to each other. So I'm going to equate this into 9 because we see the fact that this is exactly the same thing. That's why they said hens, right? So we see the fact that 10 sine theta plus x is basically equals to what? Instead of equals to this, it's equals to 9 because this and this are the same thing. Hope that makes sense. Is equals to 9. And now we're solving for x, right? We're solving for x. What you call this here? We're going to be solving for x, right? So with solving for x, we're going to have the following. So we know the fact that this is the same as what? This is the same as sine. Then this is going to be theta plus x is equals to what? To 9 over 10, right? So we have this, right? So what I'm going to do is that I'm going to take the 10 to the other side so we can have the same trig ratio. So we see the fact that we need sine, and this is going to be theta plus x is equals to 9 divided by 10, right? So we have that. Then we see the fact that we have a slight problem is that we have theta and x, so both are known, so but we have this already. And the reason why we have this, let's look at the first question, right? They already told us that 10 theta is equals to 8 over 6. So we can solve for theta alone, right? So we have that, right? So we have that, but we know the fact that, but we know, right? We know that, right? 10 theta is equals to what? Is equals to 8 over 6, right? This is given in 5.1.1. Hope that makes sense, right? So that's the given information. So we know that. So we can solve for theta. So theta is basically equals to arc10, right, of 8 over 6. Punch that into the calculator. We see that theta is equals to what? Is equals to 53, right, comma 13 degrees. So we have that, right? So now let's clean this up. So this is the same as having sine, right? Sine, then it's going to be 53, comma 13 degrees plus x. Remember the fact that we're solving for x is equals to what? Is equals to 9. It's equals to 9 over 10. Hope that makes sense, right? So now remember the fact that we're solving for x is that we need to find the reference angle. So we need to find the reference angle. So reference angle is this trig ratio, arc10 of this trig ratio. Then is this, right? Always the positive number. Always the positive number of this. So if this was negative, you're going to take the positive number. So the reference angle is equals to what? 2, right? Then it's going to be 9 over 10. So we see that our reference angle is going to be 64,16 degrees, right? Then remember, if we go back to here, now we're going back to here, right? We see the fact that this is positive, so meaning our solution is going to be where sine is positive, right? So if we draw the diagram, right? If we draw the diagram, and maybe let's just draw it here, right? So if we draw the diagram, which is this, right? We see the fact that this is all students take coffee. So where is sine positive? Is positive in the first and the second quadrant. So that's where it's positive, right? So in the first quadrant, it's going to be what? It's going to be just theta, or theta makes it confusing. It's just the reference angle, right? It's just going to be just the reference angle. That's what it's going to be, right? Then here it's going to be what? It's going to be 1. So this is 180, right? So it's going to be 180 minus the reference angle. Then here it's going to be 180 plus the reference angle, right? Here it's going to be negative the reference angle, or you can say 360 minus the reference angle. So either or, right? Either or. So for the last one, right? So we see the fact that with us it's going to be here and here, right? So now dealing with the first quadrant, right? So dealing with the first quadrant, so it's going to be the first quadrant. So the first quadrant, right? We know the fact that it's just a reference angle, right? So, but it's very important. Remember the fact that inside, looking at what we've cleaned up, right? Inside is that our angle now is not just x alone, but it's 53,13 plus x. So this is going to be our number, like our number that's going to be on the other side, right? Then it's equals to the reference angle, which is going to be this. Hope that makes sense, right? So this is going to be what? And just to make sure, this is going to be, basically this is going to be plus, then since it's thing is going to be 360, then the same thing with here is going to be plus, right? Okay, hope that makes sense, right? So it's going to be the first quadrant, so it's going to be the angle that is in here, which is in our case, this is the angle, so it's going to be 53. So it's going to be 53, right? Comma what? Comma 13, right? Plus x is equals to what? It's equals to the reference angle. So our reference angle, remember the fact that it's 64, comma 16, right? It's going to be plus k, then it's going to be 360 degrees, right? So we're going to have that, right? So now let's clean this up, meaning I want this as x alone. So I'm going to take this to the other side. So when I take it to the other side, I'm going to have x is equals to 64,16, right? Minus 53,13, right? It's going to be plus k, then 360 degrees, right? So it's going to be plus k 360 degrees, right? So now let's cleaning it up. We see the fact that we're going to have that x is equals to what? It's going to be 11,03, right? Degrees. Then it's going to be plus k 360 degrees, right? This is the general solution. We don't want that. We are about to clean it up more, but before cleaning it up, we're going to go to the second quadrant, right? So with the second quadrant, it's going to be this one. So it's going to be the second quadrant. So this is O, right? So this is going to be O. In the second quadrant, right, is going to be the same angle, which is going to be 53,13 plus x is equals to, remember the fact that it's 180 minus the reference angle. So it's going to be 180 minus the reference angle, which is our reference angle is 64. So it's going to be 64,16 plus k 360 degrees, right? So let's clean that up. So when we clean it up, we see the fact that we're going to have the following. We're going to have that x is equals to what? To 180 minus 64,16 minus 53,13, right? And this is going to be what? This is going to be plus k, then this is going to be 360 degrees, right? So when you say 180 minus, so this whole thing, right? This whole thing, when you punch it into the calculator, you're going to get the following. You're going to get that this is going to be x is going to be equals to what? It's going to be equals to 62,71 degrees plus k is equals to 360, right? Then this is not our final solution. This will be our final solution if we didn't have a restriction. Remember in our question, they say the fact that x is an element between 0 to 360. That is the restriction, right? So we know the fact that our x, so we know, so we need to find, we need to find, so we need to find when x is between 0 and 360. If they didn't give us a restriction, is that we were just going to end here, but we need to find that, right? So what to do that is that you need to do like trial and error, right? So meaning we're going to pick k, right? K, I always start at -2, right? I'm going to pick k from -2 and I'm going to find -2, -1, then until I get it within this restriction. Hope that makes sense, right? So we're testing the general solution so that we make sure the fact that is within that restriction, right? So we're going to start with k is equals to -2. So now in both of them, right? In both of them, I'm going to substitute -2 and find what the value is. Then we're going to check whether is it between this restriction. If it is, then we accept it. If it's not, we're going to reject it, right? Hope that makes sense. So this is going to be when x is equals to 11,03 plus k, then, sorry, so k is going to be -2, right? And this is going to be 360. Then let's do the other one. So that the other one is going to be so it's going to be x is equals to 62,71. Then it's going to be plus, that's going to be -2. Then it's going to be 360. So now let's solve this one. So we see the fact that for this one, we're going to get x is going to be equals to what? It's going to be equals to -708,97. So we see the fact that this is not part of this, right? So this is a rejection by default. Then we see the fact that this one is going to give me what? It's going to give me x is equals to -657,29. We also see the fact that this is not part of this restriction. So this is also out, right? Then now we're going to test when k is equals to -1, right? So when k is equals to -1, it's going to be x is equals to 11,03 plus this is going to be -1. Then this is going to be 360, right? So we're going to do the same thing here. It's going to be x is equals to 62,71 plus -1, and this is going to be 360, right? So here x is going to be equals to what? Our x here is going to be equals to -300, and so it's going to be -348,97. We see the fact that that is definitely not part of this region, right? It's out of it. So this is not part of our solution. Then we see the fact that for this one, for x, right? For this one, we see the fact that it's going to be what? -297,29, right? We see also the fact that this one, do you see? This one is not part of the solution. It's not part of that region or interval, so this out, right? So now we're going to test. Remember the fact that after -1 comes 0, right? So we're going to test when k is equals to 0. So it's going to be x is equals to 11,03 plus this is going to be 0, and this is going to be 360, right? And the other side is going to be x is equals to 62,71, right? Plus 0, then this is going to be 360. So we see the fact that here x is going to be equals to 11,03, right? And let's go up, right? We see the fact that this 11,03 is part of this interval. So this is part of our solution, right? Then here we see that x is equals to 62,71, right? We see the fact that again, even this one, right, is part of this interval. The 62, let's unzoom it, is part of our interval, right? So our interval, let me just put this interval in like a bright color because, yes, right? We see the fact that that is part of our interval, right? So we see the fact that this is part of our interval. So let's do this. Let's do this so we can see it. We can mark it. So we know the fact that this in green, right? And also this one in green. So we see the fact that both of them are part of our interval, right? Green. Wow. So we see the fact that this is, yes, in green, right? So we see that is that. But we do not stop. We stop until we get a rejection, right? We see the fact that we got here, we got rejection, then we got an acceptance. That's the green one, right? Now we need to basically do it till we get to like a rejection. Then when it's a rejection, then we stop there, right? So now we're going to find when k is equals to 1. So when k is equals to 1, it's going to be x is equals to 11,03 plus this is going to be 1. And this is going to be 360, right? So now when k is equals to 1, so this is going to give me what? This is going to be when x is equals to what? X is equals to a positive 371,03. We see the fact that this is way above 360. So also this is not part of our solution. So here it's going to be when x is equals to 62,71, right? plus this is going to be 1, this is going to be 360, right? We see that x here is going to be equals to what? Our x here is going to be equals to 422.71. We see that this is not part of our solution. So since now we have rejection till we got to an acceptance, right, and we get a rejection, we can end here because we know the fact that anything below this is going to be a rejection. So our final answer, so therefore our final answer is when x is equals to 11,03 and when x is equals to 62,71. Hope that makes sense. So that is the final answer for this question, right? So now we're going to do 5.2, which is reduction, right? So we're going to use this diagram, we're going to use this diagram to basically solve it, right? So now we're looking at our equation is that we have cofunction here, right? And then we have the normal reduction, and here we need to reduce it, right? And this normally they're gonna probably say the fact that solve without using a calculator. They didn't say this here, so that's what we're gonna do, right? Is that chances are this is special angles, right? So now let's clean it up, right? So what I'm gonna do is that I'm gonna individually take them out, right? Solve them individually and put them back, right? So we see the fact that for cos, so we're gonna say for cos 90 degrees plus x, right, is going to be equals to, let's go back to our diagram, right? 90 plus x, so 90 plus x, we're going to take the highlighter. 90 plus x is going to be this one, right? We see the fact that 90 plus theta, which is theta in our case is x, right, is equals to negative sine theta, meaning in our case this is going to be equals to negative sine, right, negative sine x. Hope that makes sense, right? So we've cleaned that part out, right? Then now we're going to move to what? We're going to move to the second one, which is going to be cos. Then this is going to be x minus 180 degrees, right? This is that we need to clean it up. This always is in front, and this x or theta is always that follows. So we need to clean it up. So let's swap them. This is the same as cos, then this is going to be minus 180, right, minus what, plus x, right? So this can never be a negative, it needs to be always positive. So we need to clean it up, meaning we're going to pull out the negative. So when we pull out the negative, this is going to be the same as cos, then just in a square bracket pull it out. So it's going to be whatever that was positive becomes negative, the whatever that was negative becomes positive. So this 180 is going to be positive and this x is going to be negative, right? So let's do this, right? So now this whole thing, do you see this whole thing? We're going to take it as an angle, right? We're going to take it as theta. So this whole thing is going to be like theta, right? Reason why is that I'm going to apply one of this, right? We see that a negative theta of what you call this, of course, always gives you a positive. So this we can rewrite it as what? This can be rewritten as cos, and this is going to be the same as 180 minus x. Hope that makes sense, right? So now we're going to go back to the diagram and look for 180 minus x. So we see the fact that 180 minus x, right? So 180 minus x, so it's going to be cos 180 minus x. We see the fact that it's this one, right? It's going to give me a negative cos theta, which is in our case, it's going to be equals to negative cos x. Hope that makes sense, right? So we sorted out that one. So now we're going to move to, so let's do this, right? Now we're going to move to 10. Okay, we're going to move to 10. So we're going to move to 10, 360. 360 plus x, right? So we go back to the diagram, we look for 360 plus x. We see the fact that 360 plus x is going to be what? 10 360 plus x is positive. So this is going to be equals to 10x. So we sorted with that one, right? So now let's clean up the cos, the denominator, 240, right? So we know the following, right? We know the fact that we need to write 240 in such a way, the fact that it's going to be 180 minus 360 plus, something like that, right? So that we can use reduction. So we see the following. We see the fact that 240 can be written as what? 240. So 240 is basically equals to what? It's equals to 180 plus 60. So when you add this, you get this, right? So now, meaning I can replace this 240 by this, right? So we know the fact that this is the same as what? So this is the same as cos, and it's going to be 180 plus 60, right? So 180 plus 60 is going to give you 240. So let's put this maybe inside like a thingy so that you guys know, right? We know the fact that that is that. So here we can apply reduction, but instead of theta, we have 60 degrees, right? So we know the fact that this is the same as what? This is the same as cos. Then 180 plus, right? Remember, but our theta in our case is 60, right? So it's going to be cos 180 plus. So 180 plus is here. So cos, so it's here. So this is going to be minus cos theta. So it's going to be minus, in our case, minus cos 60 degrees, right? Then we know the fact that what you call the 60 degrees is a special angle. You can punch this into your calculator. You're going to get this as being what? As being minus 1 over 2, right? Cos 60 is a half, so that is why it's minus 1 over 2. Hope that makes sense, right? So now we're going to move to 225. So it's going to be 225, right? So we see the fact that 225, right? So 225 can be written as what? We can also write it as 180 plus 45. So when you say 180 plus 25, you're going to get 225. So now I'm going to replace this 225 here by 180 plus 45. And we know that 45 is a what? Is a special angle, which is good. So this is going to be the same as 10. So it's going to be 180 plus 45, right? So now we're going to find, we're looking for 180 plus 45, right? 45 being theta in our case. So it's going to be 180 plus theta. So it's this one. We see the fact that 10 is positive. So it's going to be what? This is going to be the same as 1045. So 1045, when you punch that into the calculator, you get that this is equals to 1, right? So now we have everything sorted. So we have cleaned it up, right? So now we're going to basically put it back into this, right? So I'm going to rewrite that. So when we rewrite it, it's the same as what? So let's rewrite it right now. So we know the fact that the question was cos, right? So it's going to be 90, right? Plus theta, plus x, sorry. Theta's in my tongue right now. So it's going to be x minus 180, right? Then it's going to be 10. So it's going to be 360, right? Plus theta, sorry, plus x. Keep on saying theta. So this is going to be what? This is going to be cos. Then this is going to be 240. Then this is going to be 225. So this is going to be the first one. It's going to be minus sine x. Then this one is going to be, remember the fact that this is minus sine x. Then the second one is minus cos x. So let's go down. So it's going to be minus cos x, right? Then the 360 is positive x. Then in the denominator, so let's clean that up. So it's going to be in the denominator like this. So we know the fact that the 240 is a half. So this is going to be negative a half. And lastly, this is going to be 1, right? So we have that, right? So now we have that. Now let's clean it up right further. So this is going to be the same as this negative, and negative is going to give me positive. So this is going to be the same as sine x multiplied by cos x, right? And this is going to be 10x, right? And this whole thing is going to be divided by what? It's going to be divided by negative a half multiplied by 1 is the same as negative a half, right? So I'm going to just take the half to the other side, right? So this is going to be before even applying the identity here. to further simplify it. This is the same as sine x, right, multiplied by cos x, right, multiplied by 10 x, and this whole thing is the same as divided by negative a half, right? So this is the same as what? Sine x multiplied by cos x multiplied by 10 x multiply. Now take this to the top and this one to the bottom. So this is going to be minus 2 over 1, right? So this is the same as what? This is the same as negative 2 sine x multiplied by cos x, right? And it's going to be 10 x, right? So now I'm going to apply this identity here. So we know the fact that here is going to be what? It's going to be negative sine x multiplied by cos x, and this is going to be the same as sine x divided by cos x, right? So now since everything is going to be multiplying here in the numerator, meaning this cos and this one are going to cancel out, so these two are going to cancel out, so we're going to be left with negative 2 sine x, right? And it's going to be multiplied by sine x, right? So this is the same as negative 2 sine squared x, and this will be your final answer for this question. Hope that made sense. So now what I'm going to do is 5.3. So it's proving the identity. So meaning what we need to do is that we need to prove that the left hand side is equals to the right hand side, right? So this is the left hand side is equals to the right hand side, right? So normally is that you take the most complex side and you solve it. In our situation is that it looks like you could take either or, then like simplify it. So what I'm going to do is, with my case, is that I'm going to take the right hand side, right? Even if you try it and you take the left hand side, it's fine. But I'm going to take the right hand side and apply the identity and come back. If sometimes it happens the fact that you need to also solve the right hand side or the other side so that they equal. So taking the left hand side, the right hand side, so taking the right hand side, right? So we know that the right hand side is 10 2a, right, divided by 10a, right? So now applying the identity, which is, so applying this identity, so applying, yeah, I'll just put it on the side, right? So it's going to be applying that 10x is equals to sine x divided by cos x. So applying that, right? So let me just put this in red. So applying this identity, right, I can write both of them, the numerator and denominator, within this identity. So this is going to be the same as sine, right, sine 2a, right, divided by what? By cos 2a, and this is going to be divided by sine a divided by cos a, right? So that's that, right? So this is the right hand side. So it's equals to that. So this is going to be basically equals to sine 2a divided by cos 2a divided by sine a divided by cos a. I'm just rewriting this in terms of division because I can simplify properly in that way, right? So I see the fact that now we have the following, right? I have that sine. So I have sine 2a, right, divided by cos 2a multiply. So this is going to go up and this is going to go to the bottom. So this is the same as cos a divided by sine a. Hope that makes sense so far, right? So now let's clean it up, meaning multiplying numerator to numerator and denominator to denominator. So this is going to be the same as sine 2a, right, multiplied by cos a. Then this whole thing is going to be divided by what? By cos 2a multiplied by sine a, right? Then now, just to go back to what we're proving, right? We see that our left-hand side has 2a. So we don't need to get rid of this 2a. We need to get rid of this one, right? Because you see the fact that here our numerator does not have sine 2a. So now we're going to apply the identity here. So applying the identity is going to be the same as 2 sine. So this is 2 sine a multiplied by cos a, right? Right? It's going to be multiplied by cos a, right? And this whole thing, right, is going to be divided by what? By cos 2a multiplied by sine a, right? So I'm just going to write the identity. We know that sine 2a is basically equals to 2 sine a multiplied by cos a. So let's put that down, right? So that is an identity, right? So we know that, right? We know the fact that that is the identity that's going to play. So now we see the fact that the sine a is going to cancel out. So we see the fact that there's 2 are going to cancel out. So you're going to be left with what? You're going to be left with 2, right? 2 cos. And we see the fact that it's 2 of them. So you're going to say cos squared a. Then this whole thing is going to be divided by what? This is going to be divided by cos. So this is going to be divided by cos 2a, right? So now we're going to look at the right-hand side, right? So let's go up. So we see the fact that the right-hand side, we have the numerator. Then we have our, basically our left-hand side, sorry. Our left-hand side is 1 plus cos 2a. And in our case, we simplify it to this and we can simplify further. So let's check whether if we take the left-hand side, can I simplify it so that it looks closer to this, right? So now taking the left-hand side, right? And we know that our left-hand side is going to be 1 plus, so it's going to be 1 plus what? 1 plus cos, right? 2a, then divided by what? Divided by cos 2a. So our goal here, right? Our goal here is to make this one look like this. That's our goal, right? So now doing that is that cos 2a has a bunch of identities, right? It has a bunch of identities. Let's write them down. So we see the fact that cos 2a. So the identities for cos 2a, the first one is going to be cos, right? Cos squared a, right? Minus sine squared a. Then the next one is going to be 2 cos squared a minus 1. And lastly, lastly is 1 minus 2 sine squared a. So these are the 3 identities, right, for cos 2a, right? But remember the fact that within our case is that we want this. We want cos squared x, right? So we see the fact that the identity that can give us closely to that is this one. If I pick this is a problem. If I pick this one is a problem. But this one, I feel like I can achieve to getting this so that they can be equals to each other. So now applying that one is going to be 1 plus, then it's going to be 2 cos, right? Squared a minus 1, right? And this is going to be divided by what? Divided by cos 2a. Right? So let's clean it up. We see the fact that it's going to be 1 plus 2 cos squared a minus 1, right? And this whole thing is going to be divided by cos 2a, right? We see the fact that this and this are going to cancel out. So we're going to be left with 2 cos squared a. And this is divided by cos. Sorry about that. This is going to be cos 2a. Then let's zoom it out. Do you see the fact that this and this are now equals to each other? So you have proven it. So therefore, the left hand side is actually equals to the right hand side. And that's how you would solve this question. Okay, now we're going to do question 5.4, right? It says if sine 32 is equals to t, then we need to determine sine 16 in terms of t, right? So one key note is that 16 is 2 times, right, of 32. So if you say 2 multiplied by 16, then you're going to get 32, right? So that's very important. So first thing that we know the fact that that is important. We know the fact that 32, The relationship between 32 and 16 is that 32 is equals to 2 times of 16, right? So that's what we know, right? So why this is going to be very important is going to come, let me just do it now. Why is it important, right? So we know the fact that this is the relationship, right? So now we know the fact that if we're going to be using compound angles, so if we're going to be using compound angles like this, right, is that where can we get 16 alone? So basically we said we need to find a formula, right, within the identities where we can get it along. So let's go up, right? To remember the fact that we did this one. So let me just copy and paste this. No, I want to copy and paste it. And I am putting highlighters. So copy and pasting. So copy it, paste it. Okay, cool. So we know the following, right, from this identity. So we know the following. So I'm just going to paste it here, right? If we make a 16, right? So let me just do this. Delete it. If we make a 16, so I'm going to put it 16 here. So this is going to be 16 and this is going to be 16. And also here, we're going to have 16, right? And also here, we're going to have 16, right? So we see the fact that within the three options, right? And the other one that is a compound is when sine, right? So it's either sine 2, then this is going to be 16. Is equals to one identity, right? So within that one identity, let's just put it here in the bottom. So let's do here. We know the fact that that one is equals to what? Is equals to 2. So it's going to be equals to 2 sine 16 multiplied by cos 16, right? So we know that, right? So we know that. So my goal is what? To have 16 alone, not with cos, not plussing it with cos. And we see the fact that the only one that can make us arrive to that one is this one. So remember, sine is this one. 16 is alone, so we can basically isolate sine 16 from that, right? And we know the fact that already we can rewrite it in terms of, like, we can find cos 36 of this, right? And rewrite it in terms of this. Hope that makes sense, right? So we know the fact that we can find cos 16, 2 multiplied by 16, because of that is 32, right? Then from there is that using this and making this one the subject is going to be the easiest. Hope I didn't confuse anyone, right? So we know the following, right? We know, so with that said, is that we know the following. We know that we're going to basically rewrite. So let me just do that first. We know the fact that we can write what we want, which is cos 16. So it's going to be cos 32, right? 32 is the same as cos. It's the same as 2, right? 216. So we know that, right? Then we're going to apply the identity that has 16 only. So it's going to be 1 minus what? 1 minus. So this is going to be the same as 1 minus 2 sine, right? Sine squared. And this is going to be 16, right? So now we know the fact that cos 32 is equals to that, right? So our goal now is to make sine the subject. So goal, make sine 16 the subject, right? So make sine 16 the subject, right? So let me just put this inside the block. Yes. So we're going to make sine 16 the subject, right? So now making that is that we're going to take what? We're going to take everything to one side. So meaning this is going to be the same as cos 32, right? It's going to be equals to, so cos 32 is going to be 32 minus what? Minus 1 is equals to minus 2 sine squared 16. So let me just swap them like this. So this is the same as minus 2 sine, right, squared 16 is equals to what? To cos. So this is going to be cos. It's going to be cos 32, right, minus 1, right? So now we want, remember the fact that the goal is we want sine 16 alone. So divide both sides by 2. So it's going to be sine squared 16 is equals to cos 32 minus 1, right? And this is going to be divided by what? This is going to be divided by negative So this is going to be divided by negative 2, right? So remember again, we want what? Sine 16 alone. So we need to get rid of this. So this is the same as writing it as sine 16, what they want, all squared. And this is going to be cos 32 minus 1. And this is going to be divided by what? This is going to be divided by negative 2. Right? So square root both sides. So when we square root both sides, this is going to be the same as sine 16 all squared, right? And this is going to be equals to the square root, right, of cos 32 minus 1, right? And this is going to be divided by negative 2. So this is going to be divided by negative 2, right? So that is going to be that, right? So now we know the fact that sine 16 is basically equals to the square root of cos 32 minus 1. And this is going to be divided by negative 2, right? So it's going to be divided by negative 2. So now, do you see the fact that we have written sine 16 in terms of having this 32? So now we will need to get rid of this cos 32, right? How can we get rid of it so that it's in terms of t? Because that's what they gave us, right? So now taking, why do I keep on doing that? So taking the information that they gave us, the if, so which is sine 32, right? They tell us the fact that that is equals to t, right? Remember the fact that sine 16 needs to be equals to t2, right? So we know the fact that using the Cartesian plane, right? So using the Cartesian plane, so let's do this. Using the Cartesian plane, right? We know the fact that 32, where's the angle 32? 32 is between 0 and 90. So it's going to be here in the first quadrant. So it's going to be here. So it's going to be here because 32 is between 0 and 90 because it's an acute angle. So it's going to be here, right? And this is 32, right? So that's 32. We know that sine is opposite, right? It's opposite over hypotenuse. And this is the same as divided by 1. So this is going to be opposite. So this is going to be t. Then hypotenuse is going to be 1, right? So now we can find using theorem of Pythagoras, we can find what y is, right? So everything is positive. So we know the fact that we're looking for y is equals to, so this is the same as r squared is equals to x squared plus y squared, right? So r squared, we know the fact that that's 1 all squared. X squared, I made a mistake. I lied here. This is x, right? This is x. So remember the fact that y is the one that's parallel to the y-axis and x is going to be on the x-axis. So this is the same as x squared, right? Plus then this is going to be what? Our y, which is going to be t all squared, right? So this is the same as 1 and this is going to be x squared plus t squared. Take the t to the other side. So this is going to be the same as, let me just do this, right? So this is the same as 1 minus what? Minus t squared is equals to x squared, right? So now square root both sides. So this is going to be the square root of plus or minus, right? In our case, it's going to be 1 minus t squared is equals to x, right? But we know the fact that x here is in the positive side, right? So therefore, we know that x is basically equals to the positive square root of 1 minus t squared. So we know the fact that x is equals to square root of 1 minus t squared, right? So 1 minus t squared. So now our diagram is complete. Do you see the fact that now I can find what? We can find cos 32 using the diagram. Right? So we see that cos 32 is equals to what? To adjacent, right? So it's adjacent over hypotenuse. So it's going to be square root. So it's going to be the square root of 1 minus t squared, right? It's going to be 1 minus t squared, right, divided by 1, which is the same as cos 32 is equals to the square root of 1 minus t squared, right? But now we're not done. Remember the fact that we're still looking for this, right? So we're still looking for this. So duplicate it, cut it, right? So now we know the fact that therefore this is equals to what? Replace this by this, right? So it's going to be what? It's going to be square root, right? And this is going to be the square root again of 1 minus t squared minus 1. And this whole thing is going to be divided by what? By negative 2. And this whole thing is within the square root. So sine 16 in terms of t is going to be equals to this. Hope that made sense on how to basically solve this question. So now we're going to do 5.5. It says given that cos x plus y minus cos y x minus y is equals to negative 2x plus multiplied by sine y, right? Then we need to prove the identity. So we know the fact that cos, so we know the fact that, let me just write it. Let me just erase it. Yeah. So we know the fact that cos x plus y, right, minus cos x minus y is equals to negative 2 sine x multiplied by sine y, right? So we need to prove that left hand side is equals to right hand side. We know the fact that this is your left hand side and this is going to be your right hand side. As I said, the fact that you always take the most complex. So the most complex is my left hand side, right? So we know that the left hand side is equals to cos x plus y, then minus cos x minus y, right? So applying the identity. So this is the identities that are going to be applying. So we know the fact that cos A plus, right, plus B is going to be equals to what? To cos cosine. So it's going to be cos A multiplied by cos B. Then the sine is always the opposite. With remember the fact that we did it, I think, with sine. Let me just look for that. Yes. No, this is compound. Let me just go back. I hope it's there. Okay. Yes. Remember the fact that with this identity, right? With yes, it's up. Remember with this one is that the sign maintains its same. With the cos one, right, it changes, right? So it's always the opposite sign, right? So let's do that. So since here it's positive, meaning this is going to be minus, right? Then this is going to be sine A multiplied by sine B, right? Then the other one is cos, then it's going to be A minus B, right? Is equals to what? Is equals to cos A multiplied by cos B plus sine A multiplied by sine B, right? Hope that makes sense. So this is the identity that we'll be applying. So I'm going to put it inside a block like this, right? So it's going to be like this, right? So now with that said is that we see the fact that we have plus and the negative. So now let's apply the identity, right? So for this one, and I'm going to put inside the square bracket, this is the same as cos x, right, multiplied by cos y minus sine x, right, then multiply by sine y, square bracket minus, then we're going to apply for the one with the negative. So this is the same as cos what? Cos x, right, multiplied by cos y. Let me just move this a little bit further, or just move it like a little bit on top. Yes, right. So go back. So let me just move it properly. So yes, here on top, right? So this is going to be what? Plus, right? For the negative one, it's going to be plus sine x multiplied by sine y, right? So now this, let's clean it up. It's going to be cos x, right? Then it's going to be cos y minus sine x sine y, and this is going to be the negative. We're going to distribute it, so it's going to be minus cos x, then cos y, then it's going to be minus sine x, then sine y, right? So now we're going to group items. So I'm going to highlight them. So group items, we see that this, and this is the same thing. Then we also see the fact that this and this is the same thing, right? So now, since both of them are the same thing, we see the fact that for this yellow one, they're going to cancel each other because one is positive and one is negative. So that is going to cancel each other. So we're going to say this cancels out each other. Then this 2 is that they're going to add up, right? So meaning this is going to be the same as negative 2 sine x sine y, right? So let's go back. That's exactly what we're proving. So we see the fact that that is exactly equals to the right hand side, right? So that's how you would solve this problem. So now we're going to do 5.5.2. It says hence find cos a minus b is equals to 2, then a plus b. So what they gave us, right? So now let's find the hence, right? So remember the fact that hence is what we were proving previously, right? So hence means in our case this, right? So this is our hence. So let me just this one. So this is our hence, right? Duplicate it, cut it. So this is our hence, right? So this is our hence, right? So now we need to look at what is like the relationship between the two, right? So let me just put this inside a block. That is our hence, right? So we see, now we need to see the relationship between the two. We see the fact that this cos here, we have cos here, we have cos here, we have cos here, right? And we have a negative and we have a negative. So we see the fact that this a is actually equals to x plus y, and this b is equals to x minus y. And we see the fact that here it's in terms of x plus y and x minus y. So what we need to do is that we see the fact that basically we're going to say let a equals to x plus 1, x plus y, which makes sense, right? Because that's the same thing. Because remember, hence is that we're using what we have previously, and b is going to be equals to what? To x minus y from here, right? Then basically we're going to name this equation 1, right? And this is going to be equation 2, right? So now basically what we have done, the first part, is that we have replaced this by a and b, which is correct, right? But now our goal is to replace this x. Remember the fact that the relationship between the two is that I want to rewrite this in this form, right? So my goal is to replace this x and y, right? So we see the fact that we have this relationship. We know the fact that if we find a plus b, we can use this, what we used. So we can find a plus b and a minus b, right? And basically try to solve for x and y. Hope I'm making sense, right? So from what we given, taking what we given, we know that a plus b, right, from this, right, we know the fact that a plus b, so a plus b, we're going to write it the way it is here, but we know the fact that we can represent it in terms of what? In terms of x plus y. So as we know the fact that this is the same as x plus y, and plus this is going to be x minus y, right? So let's clean that up. So we know that a plus b is equals to what? It's going to be equals to x plus y, right, plus x minus y, right? So we see the fact that the y's are going to cancel out because the one is positive and the other one is negative. So we see the fact that this and this is going to cancel out, right? So a plus b is basically equals to 2x, right? So now cleaning that up, right, we see the fact that we can solve for x alone, right? So this is going to be the same as what? This is going to be the same as a plus b is divided by 2 is equals to x, right? So now we have x, right? Now let's do for y. So now let's do for y, right? So for y is that we know the fact that we can find a minus b and write it in terms of what? In terms of x plus y, right? So it's going to be a minus b, right, is equals to what? Is equals to x plus y, right, minus x minus y, right? So this is going to be a minus b is equals to what? Is equals to x plus y minus x, and it's going to be plus y. So we see the fact that now our x's are going to cancel because one is positive and one is negative. So this is going to be a minus b is equals to what? Is basically equals to 2y. So divide both sides. So when we divide both sides, we see the fact that a minus b is basically equals to divided by 2 is equals to y, right? So now this is perfect, right? So meaning I can take this, right? I can take this, and looking at what we solved, we know the fact that a is this, b is this, and now I know that my new x is this and my new y is this. So taking exactly the red part, let's just take it. Taking the red part, so duplicate it, cut it. So I'm just going to put it here, right? So let's do this. So delete this, right? So taking now the red part, right? We know the fact that we let, so let me just do this. So we know the fact that our a is what? Is x plus 1. So remember the fact that we said let a equals to x plus 1. So I'm going to replace everything in terms of a and b, right? So we know the fact that this is the same as what? This is the same as cos a minus cos b is equals to cos a. So cos a minus cos b, right? From that, then we know the fact that this is going to be equals to negative 2 sine. What is our x? Our x is a plus b divided by 2 multiplied by sine. What is our y? Our y is a minus b divided by 2. And this is exactly, right? This is exactly this. So that's how you would solve this question. Hope that made sense, huh? So now we're going to do 6.1, right? It says in the diagram, so in the diagram below, the graph f theta is equals to p cos theta plus theta, right? Plus q, right? And it's sketched between 270. So we know the fact that it's sketched between negative 270 from here till positive 270. So in this case is that they represented x in terms of theta. So whether it's x is theta, do not worry about it. It's the same thing, right? It's just that our x value now is no longer x, but it's theta. So our y is y, but x is replaced by theta. So don't get confused, right? So we have that, right? So this is the graph. Then now it says, the first question says, write down the amplitude of what? We need to write down the amplitude of f, right? So this is the formula for the amplitude, right? So amplitude, always use this, right? So amplitude, right? Amplitude is equals to what? To the maximum, right? Minus the minimum, right? And that divided by what? That divided by 2, right? So that is the formula for amplitude. Remember it, right? It's maximum minus minimum divided by 2. So that is that, right? So in our case is that we need to find the maximum, the minimum. So let's go back to the graph, right? Where is the maximum, right? The maximum is here, right? And I'm just going to draw lines. So the maximum is linked to this one. So our maximum is 3, right? So this is our maximum, which is this 3, right? Then our minimum, so this is, I'm going to say max, which makes sense, right? Is the biggest point, right? Minimum is going to be this one. So we see the fact that this is our minimum, right? So this is going to be our minimum, right? And our minimum here, so this is the minimum. And we see that the minimum here is equals to negative 1, right? So let's write it. We know that maximum is equals to 3. Then minimum is equals to negative 1, right? Makes sense. Equals to negative 1. So now we know the fact that our amplitude, is equals to 3, right? I'm saying plus 3 minus open bracket negative 1, right? Then this whole thing is going to be divided by 2. So this is the same as what? This is going to be the same as 3 plus 1 divided by 2, which is the same as 4 divided by 2. So our amplitude is technically equals to 2, not technically, it is equals to 2, right? So that is our amplitude. So that's how you would find amplitude. So now we're going to do 6.2. It says we need to determine the range. So normally with range, we have a formula, but since we do not have the actual values, remember the fact that our graph is in terms of P and Q, we do not have that, right? So I can't necessarily find my P and Q, right? So with that said, is that we need to use the graph to find our range, right? So using the graph, so I'm going to say using the graph so that you know that when using the graph, this is what you'll be looking for. So using the graph, right? Using the graph, right? So using the graph, our range, right, is basically what? Is basically y is an element of real numbers, and that is going to be between the minimum value, right, and the maximum value. So that's when you're using the graph, and let's put this inside like a note. All right. So with that said, we know the fact that our minimum value, we found it here, is our minimum and maximum is -1 and 2. So we know the fact that our minimum is equals to -1 and our maximum, right, from the previous question is equals to 3. Right? So therefore, our range, right, is equals to y is an element, and that's between -1 and 3. So that's how you would find the range for this question. So now we're going to do question 1. We're going to do 6.3. We need to find P and Q, right? So I'm going to write F again, right? So the F that they gave us. The reason why I'm going to rewrite it again is that our P represents something different in this context, right? So we know that F of theta is equals to P cos theta plus Q, right? So we see that normally in our normal graph, right? So normally, and I'm going to put this in the blocks, okay? So normally our function, which is going to be y, of course, is a cos, right, theta. Then this is going to be basically, so it's going to be, let me just do this. Oh, well, okay, cool. So let me just, I'm writing it normally because of I want whatever that I'm going to give you now is the same thing that you should be using like all the time. So here is that I want to give you in the general sense so that next time when you answer this question, you're not confused, right? So normally we know the fact that this is how the graph looks, right? So this is going to be this plus P, then this is going to plus Q, right? So this is the general form of it, right? So this is the general form. So we see the fact that in our case, they replace A to P, right? So how I'm going to teach you on how to find A, right, is going to be the same thing in this context of this question is P. Hope that makes sense. But Q is Q, right? But in the general form, we know the fact that P moves the graph left or right, but A gives us the shape, right? It tells us whether the fact that, yeah, it gives us the shape, meaning when it's positive, right? So when it's positive, it's like it goes like this. So we know the fact that when it's positive, especially with cos, so let's do this, right? So when it's positive, it goes like this, right? So our graph becomes like this, right? So that's when A is greater than 0, when it's positive, and when it's negative, then our graph basically flips like this. So it continues, right? So this is when A is less than 0. I'm saying this, right, because how you find it kind of like matters, honestly speaking, right? So with that said, that's what we know. And we know the fact that Q moves it up or down. So I'm not going to just emphasize more about it, but I just wanted to emphasize about the A, which is in this question, our A is P, right? So let me just write it. So in this question, right, our A is P, right? Meaning they just changed the alphabet. It's P. Hope that makes sense, right? So now how do we find A and Q, right? So finding what? Finding P, right? But I'm gonna do it like what we're gonna do is that finding A, right? So I'm gonna say finding A, which is P in this question. I hope I'm not confusing you, because of the thing is, I'm trying to avoid finding P, because of, I feel like next time you get a similar question, you're gonna think the fact that we're solving for this P. No, we're solving for A, but they're representing it as P. Hope I'm making sense, right? I hope I'm not confusing anyone and I'm making sense, right? So finding A, right? So A is always going to be equals to the amplitude. So it's going to be the amplitude. So our A, right, is basically solving for the amplitude, right? So it's going to be what? It's going to be equals to the amplitude. So it's going to be the amplitude, right? And it's equals to the absolute of that value. So it's going to be the amplitude, the positive value of it, right? So it's going to be, A is going to be always the amplitude. So this means what? This means the positive value. So this means the positive value. So regardless of whether you get your amplitude as negative or positive, you always take the positive number of it. So example is that absolute of 3 is going to be positive 2, and absolute of maybe 3 is equals to 3. So if you have the absolute of this, is going to be positive. That's what it means. And this is going to be always positive. Hope that makes sense, right? So that's that. We already know that our amplitude, right? We already know that our amplitude is equals to what? Go up. We already know that our amplitude is equals to 2. Right? We've already calculated it. So we know the fact that is equals to 2. So therefore, we know that A is equals to 2, right? So we know that A is equals to 2, right? So since A is equals to 2, in our sense, right? Do you see the fact that our graph, if we go back on it, so in the normal sense, if A is positive, it needs to start here, and then it goes down. Right? Then if it's negative, it needs to start here, it goes down. So now we need to give it a sign, right? We need to give it a sign, right? So we see from our graph is that, do you see the fact that it starts here? Meaning our A is negative. Do you see? Because it's starting here, right? Do you see the fact that it's starting here? So meaning our A is negative, right? So meaning our A is negative. So therefore, since, right, our graph, so since our graph, right, is like this. So let me just, so since our graph is like this, right, therefore our A needs to be what? Needs to be negative 2. Hope I didn't confuse anyone, right? Since our graph is that, so therefore we know that P is equals to negative 2, right? Because it flips it over. So therefore our P is equals to negative 2. Hope I didn't confuse anyone. Then now finding Q, right? So now we're going to be finding Q, right? So finding Q, this is going to be the formula for finding Q. So let me just give you guys the formula for finding Q. So Q is equals to the maximum plus, not minus, the minimum, right? And divided by 2. So it's going to be divided by 2. So we already know that our maximum is 3. And we know the fact that our minimum is equals to negative 1, right? So now we know that Q is going to be equals to, so let's do this, put this inside. So it's like a formula that you need to know, right? So this is going to be our maximum. So it's going to be 3 plus negative 1. And this is going to be divided by 2. So therefore, Q is going to be equals to what? It's going to be 3 minus 1 divided by 2. So therefore, our Q is going to be, it's going to be 2 divided by 2. So Q is going to be equals to 1. So our Q is equals to 1. So this is our final answer, is that our P, right? Our P is negative 2, right? And this is going to be a Q, right? And remember the fact that here, since we know the fact that that is A, right? That is why we basically solve for P. Hope I didn't confuse anyone, and that's how you would answer this question, Anna. So now what we're going to do, we're going to do 6.4. Within 6.4, they say on the same set of x's, sketch the graph g theta is equals to negative 10 theta for within this interval, right? So what we're going to do is that I'm going to be using a calculator. So we're going to go straight and use a calculator. That way I can show you the easiest way to do it, right? And then when we're done is that I'm going to just show you how it looks, obviously sketching it from here, right? So now I'm going to just sketch the graph using the calculator, right? So we know the fact that we need to sketch the graph. I don't know why I'm saying we know that, but this is how you're going to be doing it. So the first thing, you're going to go to mode, then after mode in this calculator, you're going to go to option 7, which is table. So you're going to be looking for table, right? So you're going to click option 7 in our case. Then you're going to put in the function, right? So ours is negative 2, right? Then 10. Then remember the fact that it's theta, but we're going to represent theta as x, right? So it's the same thing. So it's going to be alpha. So going to the alphabet, then close. Then you're going to close your bracket. Then you're going to say equals to. Then we do not have a second graph, right? We only have this one. So we're going to say equals to because we don't want to put anything there. Then where does it start? Remember that our restriction is negative 270, right? Then it ends at 270. That is the interval that they gave us, right? Then steps. This is very important for 10, right? For 10, make sure the fact that your steps is 45, right? Because of 45 is where the graph curves. So don't make it 90. For cos and sine, make it 94, but for 10, make it 45. So we're going to say 45, then we're going to say equals to. And this is going to be the table. So this is going to be your table, right? So this is going to be the table. So now I'm going to rewrite the table where I'm going to represent x as being theta, and f of x, which is in our case is g of x, is going to be a g of theta. So this is how the graph is. So these are basically coordinate. This is going to be the x-axis and this is the y-axis, right? So that's what we're going to have, right? So now let's go back to our table, and I'm going to show you our table, which is exactly this. It's just that we changed the top part. Hope that makes sense, right? So these are the coordinates, right, for what we got. So this is exactly what we got from the calculator, right? So now we're going to use them to basically sketch, right? So the first thing that I'm going to do is that I'm going to highlight the asymptote, right? So wherever you see error, that's going to be your asymptote. So error, it's going to be here, here, and here. So we know that our error is going to be at 270. It's going to be at 90. It's going to be at positive 90 and positive 270. So that's going to be our error, right? So now I'm going to just draw a line going through that, right? So we know the fact that here at 270, that is our asymptote, right? We know the fact that at 90 is going to be our asymptote. We know at positive 90 is going to be our asymptote. And lastly, at 270, which is here, is going to be our asymptote, right? So we sorted that out, right? Then now we see something, which is I'm going to make it in blue, right? So the highlight is going to be blue. We see the fact that we have 0 on the g of x is going to be 0, 0, 0. That represents our x-axis, right? So that represents our x-intercepts, right? So we see the fact that that happens where at negative 180. It happens here at what? It happens here at 0. Then it happens here at 180, right? So the 0 represents the fact that that's going to be the x-intercept, right? So now let me do that, right? So we know the fact that it's going to be our graph basically cuts here, right? So it needs to cut there. Then it's going to cut where? It's going to cut at 0. Then it cuts again at positive 180. So that's very important, right? Then lastly, the reason why I said we should do it in 45 is that the 45 is going to represent something different. It's where the graph curves. It makes it a little bit easier to draw the graph, right? So we know the fact that the graph, basically where you see numbers, you see here at 2, right, at negative 2, right, at 2. So here, right, that's where the graph curves, right? So we know the fact that here it's going to curve, here it's going to curve, here it's going to curve, here's going to curve, and here's going to curve, and here's going to curve, right? So now we're going to be looking at those points. So just go here, right? That's where the graph is going to curve. So at negative 222, the graph, the coordinate to that is negative, it's positive 2. So we see the fact that it's going to be here, right? At negative 132, we knew the fact that it's going to curve here at negative 2, right? So it's going to be like that. So at 45, right, at negative 45, it's going to be positive, so it's going to be here. So the other one, it's going to be at negative 45, it's going to be positive. At positive 45, it's going to be here, negative, right? Then it's going to be what? It's going to be here. So it's going to be like this, 135, and here at 225. So it's going to be like this, right? So what happens is that our graph goes like this, right? And here it curves. Because remember, it doesn't touch the asymptote. So that is why I'm saying the fact that that makes it easy to know where it's going to curve. So now let's actually sketch the graph, right? So sketching the graph is that we're going to connect the two. So I'm going to make it in black, right? Is that we're going to connect the 3 dots like this, right? Then it's going to curve, meaning you're going to curve it like this. Then it's going to curve up like this, right? So same thing here is that we connect the 3 dots, right? It's going to curve here. Then it's going to curve there, right? See how easy it is? So it's going to be 3 dots like this, curve here, then it's going to curve there. So that's how you would sketch your g of x. So that's how you would sketch it. So now we're going to look at 6.5, right? So they say to us, indicate on the graph, right, with the thick line, right, on the horizontal, so meaning on the horizontal, meaning on the x-axis, right, where we need to basically indicate this, right? So we need to indicate when P, right, cos theta plus Q is greater than and equals to negative 2 tan theta. What is P cos theta plus Q? This is F theta, right? And what is negative 2 tan theta? That is g of theta. So we're looking for what? We're looking for when f of x is greater than and equals to g of x. So they just decided to write it the way like that, right? So now let's understand how to find this. So is that we're looking for the one that's been eaten by the inequality is at the top. So this one is going to be at the top and this one is at the bottom, right? But we need intervals, right? We need the intervals. So we need to know which intervals to look for. So the intervals or the x values, right? So the intervals, right? Where we're going to be dividing our graph. So where we'll be dividing our graph. So where, right? We will be dividing our graph, right, is we looking for the intersection. So we're looking for when, we want when f of x, so f of theta, keep on saying f of x, f of theta is equals to g of theta. So that's what we're looking for, right? So where is that, the intersection? We see the fact that our intersection, let's do it with a different color. Our intersection is going to be here, right? So this is our first intersection. This is our second intersection. And this is our third intersection. And that's that, right? So that's where we're going to be dividing the graph. So we know the fact that our graph is going to be within this region. So it's going to be here, right? So here, right? So it's going to be here. It's going to be there. So wait. Then it's going to be here. So we're looking for our x, Okay, cool. Let me just do this. Yes. So we're looking for our x intersection, right? Our intersection between the two graphs and also the asymptote. Because remember the fact that this graph has asymptote. So our asymptote. So also here, meaning this. Okay, cool. So asymptote, we're also going to make it orange, right? So asymptote. So here, this line here, it's going to be also orange, right? So this one's going to be also orange, right? So this one's going to be also orange, right? And this one's going to be finally also orange, right? So we're looking for that, right? So I should have just, let me just do this, because so let me just duplicate it, cut, yes, because, yes. So it's also orange, right? So it's also orange, so asymptote, right? So we're looking for that, right? So now we're going to divide the regions, right? So we know the fact that this is going to be the first region, this is going to be the second region, this is going to be third region, this is going to be the fourth region, so it's going to be the fourth region, this is going to be the fifth region, this is going to be sixth region, right? And what we're looking for when f of theta is on top and the other one's at the bottom. So what I'm going to do is just to emphasize, I'm going to highlight, right? F of theta is going to be the one in green. So we're looking for when green is at top, that's going to be f of theta. Then red is going to be our 10, our G, right? So our G is going to be like this, right? So it's going to be this at the bottom. So in the first region, you ask yourself, right? So you ask yourself, is our red graph, is our green graph, remember green needs to be on top because it's the one that's eating the inequality, and the red one needs to be at the bottom. You ask yourself, is the green graph on top or at the bottom here in the first region? We see the fact that here in the first region, the red one is on top and the green one is at the bottom. So this cannot be part of our solution. Then we move to the second region, which is going to be this one, right? We ask ourselves within the boundaries, right? Is that we ask ourselves, is the green graph on top and the red one is at the bottom? Yes, it is. So that's part of our solution. Then here, which is the third region, we ask ourselves again, right? Is the red graph, is the green graph on top and the red one at the bottom? No. So this is not part of our solution, right? Then we go here, right? So we go here, right? So we go to the fourth one, right? So the fourth one again is between here and here, right? So let me just unzoom it. Do you see here and here, right? We see that green is at top and red is at the bottom. That is part of our solution, right? Then here in the small one, right? Do you see here, this one and this one? Red is on top, green is at the bottom. That is not part of our solution, right? Then lastly, this one, right? This region, right? We see the fact that green is on top and red is at the bottom. So therefore, this is part of our solution. So our solution for this one, remember the fact that they said the fact that we need to what? We need to write a thick line within those regions, right? So I'm just going to do what? I'm just going to throw a thick line. So we're going to make it red. Obviously with you, you're going to make it a different color. So with me, it's going to make it red and I'm going to make it very thick, right? So our solution is going to be, or maybe let's make it green to indicate the fact that that's part of the solution. So from here till here, that is a solution, right? Then another thick line is going to be from here to here, right? Then lastly, it's going to be here to here. But remember the fact that it's those thick lines, but it's very important to know the fact that the graph never touches the asymptote, right? So here we need to included like a circle that's like this. So basically right here is that at the asymptote we need to do an open circle. Then by the by the actual intersection, it's a closed circle, right? So we see the fact that the here, right? So let me just do this, right? Here it's going to be what? It's going to be our, so let me just do this. Yes, let's go back to solid, right? So we see the fact that here, right, since it's what? Since it's the intersection, right, that point, so it's going to be the intersection. So this is going to be a closed circle, right? But here 90 is an asymptote. So let me just do this. 90 is an asymptote. So let me just, sorry. Yes. So here it's going to be a closed circle. Then here it's going to be an open circle, right? At all asymptotes, it's going to be open. So here we know the fact that's going to be a closed circle. But this 90 is what? It's a open circle because it doesn't include that, right? 135, it's closed. then this is going to be open. So that's how it is, right? So that's how you would basically finalize your answer. Hope that makes sense, Anna? Okay, now we're going to do question 7, right? So it says in the diagram PQR, so PQR, right, are the points on the same horizontal plane. Then they tell us that PR is equals to QR is equals to M. So we see the fact that those two are equals to each other. Then since those two are equals to each other, right, since this and this are equals to each other, meaning this angle and this angle equals to each other. Since this is x, so that means the fact that this is also, so that means that this is also x, right? So let me just zoom it in, right? That means the fact that that's also x, right? Then they tell us the fact that it continues and says the fact that SP is perpendicular to PQ. So SP is perpendicular to PQ, right? And they tell us that the angle of the angle of evolution of S is from Q, right? Is Y. So they tell us that this one is Y, right? So we have everything here. Then now, with that said, is that let me just fill in this diagram, right? Since this is X and this is X, meaning this is going to be what? It's going to be 180 minus 2X. And let's just solve it here, right? We know that this angle, so I'm going to name it. So I know the fact that angle, let me name it, this P here on top, right? Right, so it's going to be that angle. So it's going to be P, so it's going to be SP, so it's going to be S, no, not S, sorry, not even S. It's going to be this angle, meaning it's going to be QPR, so it's going to be Q, right? So it's going to be QPR plus angle R1, which is this one, right, plus Q2. Q1, right, is equals to 180. So we know the fact that this one is X and R1 is the one that we're looking for, right? And this one is also X, so it's equals to 180. So it's the same as R1 is plus 2X is equals to 180. So this is the same as angle R1 is equals to 180 minus 2X, right? So this angle here is, it's going to be 180 minus 2X, right? So that's what we have, right? So now with that said, is that we know the fact that is 180 minus 2X, we can go ahead and answer the first question, right? It says the fact that express this triangle. So I'm going to just emphasize the triangle. So we need to express this triangle, right? PQR, so the triangle PQR, so it's this triangle, right? In terms of X and M. So we need it in terms of X and also in terms of M, right? So our answer needs to be in terms of those two, right? So how can we express that, right? We see the fact that to find the area, we need to use the area rule. So the area rule says the fact that you need to take the angle, right? The angle that's between the two sides. So we see the fact that M is here and M is here. So meaning this other sides, meaning the included angle that we need to use is this one. Hope that makes sense, right? So meaning the area, so the area, right, of triangle PQR is equals to half, right? So the sides, meaning it's going to be PR. So it's going to be PR multiplied by the other side, which is going to be RQ, right, is multiplied by sine of the included angle, which is going to be R1, right? Because that's the included angle of the two sides, right? You see that? So it's going to be R1, right? So let's clean this up. This is going to be a half PR multiplied by, oh, sorry, let's substitute. So we know the fact that this is M and also this is M, and this is sine 180 minus 2x, right? So now since this is reduction, let's clean it up further. So this is going to be the same as a half. So this is going to be m squared, right? And this is going to be what? This is going to be, so using reduction, this is going to change into being sine 2x. So we know the fact that reduction is that sine, right? Sine 180 minus theta is the same as positive sine theta. So this is using reduction, right? So this is reduction, right? So this is using reduction. We're going to have that, right? Then we're going to have using identity, right? So this is going to be using identity. So this is going to be 1 over, then it's going to be m squared. So this is going to be replaced as the identity, which is going to be what? 2 sine x multiplied by cos x, right? So that's what we're going to have. So it's going to be that. So now we know the fact that, let me just do this, right? So we know the fact that that is the identity, which is sine 2x is equals to 2 sine x multiplied by cos x, right? So let me just put this inside a box, right? So that is what, using the identity, right? So we have replaced it. So now with replacing that, let's clean this up. So this is going to be the same as 1/2 multiplied by 2 m squared sine x cos x. So this one is going to give me 1. So this is going to be the same as 1. So it's going to be m squared sine x multiplied by cos x. So, and our answer is in terms of x and m. Hope that makes sense. So that's how you would find the area of this triangle. So now we need to do 7.2. So remember the fact that this is 180 minus 2x and this is x, right? So now we need to show that PQ, so PQ is this one, is equals to 2m cos, what you call cos x, right? We see the fact that our PQ needs to be written in terms of m and x, right? So it's x. So we see the fact that x is here, right? So let's highlight where x is. So in green. So we know that our answer needs to be in terms of this ones, right? So now is that we see the fact that we can use what? Sine rule. Because do you see the fact that we have the side and the opposite angle, which is in terms of x, and also we can take any other side, which is I'm going to take this one and this, right? So I can have that, right? So that's what I'm going to do. So using sine rule, right, is that I know the fact that PQ, so PQ, right? So PQ, remember the fact that the side that matches up with PQ is this one. So this is the angle. So it's going to be PQ divided by what? By sine R1, right? Is equals to, then I'm going to take this angle and its side, right? So the side meaning it's going to be QR because we started with the side. So it's going to be QR, right? Divided by sine. Then that angle is what? Is QPR, right? So now let's substitute. So we're looking for PQ is divided by what? Divided by sine. And this is going to be 180 minus 2x, right? And this is going to be equals to what? So QR is going to be m. And this is going to be divided by sine x, right? So let's clean it up. So it's going to be PQ, right? It's going to be divided. This is the same as sine 2x is equals to m. Then it's going to be sine x, right? Cross multiply. So when we cross multiply, take it to the other side. So it's going to be just take this. Basically, we're going to take this to the other side. Since it's dividing, it's going to multiply. So this is going to be the same as PQ is equals to m. Then it's going to be sine 2x divided by sine x. Let's clean it up. So we're going to apply the identity, right? So it's going to be PQ is equals to m. Then this is going to be 2 sine x multiplied by cos x. And this whole thing, right, is going to be divided by sine x. We see the fact that this sine and this sine are going to cancel out. So PQ basically is going to be equals to 2m cos x, because these two are going to cancel out, right? And remember the fact that here we apply the identity that sine 2x is equals to 2 sine x multiplied by cos x. So let's put this inside the box, right? So that's how you would basically solve this question, because of it's exactly what they want is 2m cos x. So that's how you would solve this question. So now we're going to do 7.3. It says hence, right? Remember hence that we need to use whatever that we got previously. So our hence in this situation, so our hence, right, is in this situation is that we know the fact that PQ is equals to 2m, right? 2m cos x. So remember the fact that this is our hence, right? So I'm just going to put inside the block. So we need to use that, right? So with that said is that our hence, so I know the fact that this is going to be updated to 2m, right? Cos x, right? So they say hence from our previous one, we need to show the fact that SP, so let's highlight it. So SP, which is this one, right, is actually equals to what? It's equals to this, right? So now we see the following. We see the fact that this is a right angle triangle, right? So we see the fact that this is a right angle triangle, meaning I can use trig ratios, right? We see the fact that our y is, we have y, so meaning y is very important. So we see the fact that y is going to play a role, right? And we see the fact that we have 2m, so this needs to play a role, right? And we're looking for this one. So we know the fact that if we go to what we want, which is going to be opposite, and what we also need to be in our solution is adjacent, that's 10, right? So we're going to say 10. So it's going to be 10 of that angle, which is y, is going to be equals to opposite is SP, what we're looking for. Then adjacent is going to be PQ, right? But we know that PQ is equals to that. So it's going to be 10. Y is equals to what? Is equals to SP divided by 2m cos x, right? So take it to the other side. This is going to be the same as 2m cos x multiplied by 10. Y is equals to SP, which is exactly what they wanted, right? So we know the fact that therefore our SP is technically equals to 2m cos x 10 y. And that's how you would answer this question. Hope that makes sense, Anna. So now we're going to do 8.2 under Euclidean, right? So with that, before we just start, right, is that question 8.1, right? It's a proof. So I'll have the link to how to prove that certain question. So I'm not going to do it because of I already have done it before in my master Euclidean, which was my master Euclidean video. So now is that I'm just going to do questions, but I'm not going to do the proof because it's already done, right? So it's more or less of repetition. So now we're going to do 8.2, which is answering the questions. Hope that makes sense. And don't worry, is that when I put in the link to the video, is that I'm going to just put it in the description where the proof is, not the entire video. So when you click on it, it's going to send you straight to where the proof is in the whole, I think it's 10-hour video. Hope that makes sense, right? Just need to clarify that. If maybe you be like, oh, you missed a question, don't worry, I got you. It's just repetition. So, and we already done it. So you can just go there and learn the proof there. Okay, with that out of the way, we can do 8.2, right? So in 8.2, it says the following, right? It says in the diagram, wait, let me just take my highlighter, right? So it says in the diagram, right below, there's a circle. So we see the fact that we have a circle and it's passing through the point A, B, C, and D. So let's see, this is A, right? B, D, E, and F. So we see that the point touches all that, right? So since we have points on the circumference, so if we have like 4 points in total, is that we can have properties that are related to what, to cyclic quad, and also like angles in the same segment. Hope that makes sense, right? So now what I'm going to do is that from here, I'm going to highlight it in green, right? So it's going to be the points on the graph. So this points on the graph, I'm going to highlight them in green, and we're going to just look at all the properties that are related to it, right? So I'm just going to say points on the graph, so points on the circle. So it's going to be points, right? Points on circumference, right? So then I'm just going to put it, underline it. So now we're going to start with this 4 points, right? So I'm going to look whether you have angles in the same segment. So from here is that from the top. So let's start from the top. We see the vector from the top, and I'm just going to take a highlighter because I need to erase it. You know how we work. So is that if I take point A and point B, right? And within point A and point B is that I need to be able to connect, right? I need to be able to connect point A to one point and another, what you call this? I need to be able to connect A and B need to connect to one point and also need to be able to connect to another point. If that can happen, that means those angles are equal to each other. So for instance, in our case is that we see that point A can connect to point F. So that's good. Let's check whether point B can connect to F. We see the fact that that can happen too, right? So that's good. We see that also point A can connect to point D, right? That's good. And also point B can connect to point D, right? So we see the fact that this created like a butterfly. So meaning that this angle here is equals to this angle. And since it created a butterfly, we see the fact that if we create now, if we make F and D our new points, is that they're going to connect to B and A. So that's the butterfly. So since we already created that butterfly, we see the fact that this angle A is also equals to angle B. Right? So we see that, right? So now let's write that, right? So let's write what we have. So what we have is that now angle A, right, is equals to angle B1, right? So it's equals to angle B1. And the reason is going to be what? Angles in same segment, right? Then we also see the fact that angle D3 is equals to what? To angle F1, right? And our reason is going to be angles in same segment, right? Hope that makes sense, right? So we see that. We see the fact that we have that is sorted, meaning angles in the same segment, that happens, right? So we see the fact that since we have more than 5 points, meaning some sort of a cyclic quad can be formed, right? So let's erase this. So let's erase this, right? So let's erase that, right? So now if I take my highlighter, right? And when I take my highlighter, I see the fact that if I take 4 points, so 1, 2, 3, 4, right? This creates a cyclic quad. So this creates a cyclic quad, right? So this is going to create a cyclic quad, right? And since it creates a cyclic quad, we see the fact that what opposite angles of a cyclic quad creates 180. So meaning this angle plus this angle, right, is going to be equals to 180. So we see the fact that angle, let's name it angle F. So this one, right? So this angle here, right, plus this angle here, when you add them together, they need to be equals to 180. And the reason why I'm going to name this one and not this one is because this one is too complicated, and we see here it's in terms of y, right? Meaning I can simplify this one. So I'm just going to leave this one. But also I'm going to just write it that this whole angle here plus this whole angle is also equals to 180, right? So let's do that. So we see the fact that angle, so let's do this. So we see the fact that angle, let's name it, it's FED. So it's FED. So we see that F, so you see that FED is equals to angle A, right? Right? No, angle FED, sorry, plus angle A is equals to 180 degrees, and it's opposite angles of a cyclic quad. So it's going to be opposite angles of cyclic quad. Okay, we have that, right? So it's going to be opposite angles of a cyclic quad. Therefore, we see that angle FED is equals to y. So we know the fact that this is y plus angle A. So it's going to be 180 degrees. So therefore, angle A is equals to 180 degrees minus y. So we know the fact that now this angle here is 180 minus y, and also this is going to be 180 minus y, right? So we know that. So now also let's just put that other one. So meaning this angle here plus this angle here is also equals to 180. So let's name this one, right? So let's name this one. So it's going to be AFE. So it's going to be AFE. So we know the fact that angle AFE is equals to this angle plus this angle, which is ADE. So it's going to be A plus ADE, right? And that is going to be equals to 180 degrees, right? And it's going to be reason opposite angles of a cyclic quad. It's going to be opposite angles of a cyclic quad. Okay, so we have that cyclic quad. And also, if you see, if I highlight this one, see we have another cyclic quad which is starting at B. So let's do that. So it's going to be B, F, E, right, D, and and D, right? So we see the fact that that is a cyclic quad. Again, do you see the fact that this Y is equals this Y plus this Y, or plus B1 is equals to 180. And we see the fact that already it's in terms of 180 minus Y. So because of those two are also equal. So just another way to prove the fact that this is also 180 minus. Hope that makes sense, right? So there isn't anything much with this. So we know the fact that we have put in that relationship. The relationship we can put in is the fact that this angle plus this angle, they also equals to each other. So we can say what? We can say angle, so it's going to be what? It's going to be BF, so this angle here, which is going to be BFE, so it's going to be BFE. So we know that also the fact that B, so BFE plus what? So plus this angle here. Do you see this angle here, which is going to be BDE? So it's going to be BDE is equals to 180 degrees, and the reason is going to be the same as this one, right? I'm just going to do this. Hope that makes sense, right? So in terms of the points on the circumference, right, and also everything that is regarding that, I think we have covered everything that we need, right? Hope that makes sense. So now we're going to move to what? To the second part of the information. So let me just change my highlighter. Maybe let's make it this. Let's make it orange, right? It says the following, right? It says, it continues and says the fact that the tangent B and D meet at C, right? So we see the fact that we have a tangent. So the tangent line is this tangent here, right? And also this tangent here, right? So since both tangent are coming and meeting here at C, that means the fact that these two are equals to each other. So let's make it orange. So we know the fact that these two are equals to each other. So we know that this one is equals to this one because of its tangent line meeting at the same point. Because of this two, this BC is equals to this BD because of they meet here at C. Hope that makes sense, right? So I'm going to say tangent line, right? So I'm going to say tangent. So I'm going to say tangent. So the first one is that we know the fact that angle B, so B2 is equals to angle D, D4. And the reason that is tangent from tangent to same point, because they're all going to the same point with this C, right? Tangent to same point. Right? So we have that, right? So we have that. Then now we're going to look at 10, at 10 chord, right? So I'm going to start with this one, right? So let me just do this. So I'm going to start with this tangent, right? I'm going to start with this one from this side. So we know the fact that this is a tangent, right? And a tangent line. So now this is going to be its chord that is subtended. So this angle B2, right, needs to be equals to, let's create a triangle like this, right? So we're going to create a triangle. Make sure the fact that all points touch the circumference, right, of the triangle. Then we see the fact that this is equals to this. So these two are equals to each other, meaning this is X and also this one is X, meaning by default this is also X, right? So we see the fact that angle B2, right? So angle B2 is equals to what? Is equals to angle F2, which is equals to x, and our reason is 10 chord. Right? Then we also see the fact that if now I move the tangent, so go to the other side, so we move the tangent line to this side, right? So this is the tangent, the chord that is subtended to it, meaning this angle D4 needs to be equals to, so create a triangle. Again, we see the fact that this is equals to x again, which makes sense because like also we've proven it with opposite angles, right? Since the two tangent lines are equals to each other. But we can just write it, right? We see the fact that angle D4, so angle D4, it's equals to what? It's equals to angle F2, right? Which is equals to x, and the reason is going to be 10 chord, right? So that's that, right? And we see the fact that then that is the rest of the information and we sorted, right? So now I think we can go and start answering the questions. So now what we're going to do is that we're going to answer the question. They say to us, express the following, right, in terms of x and y, giving reasons. So we're going to start with B2. So what I'm going to do is that we're going to go back to our notes, right? We already know that B2, so we already know that B2, right? So we know the fact that B2 is equals to F2, which is equals to 10 chord. So that's going to be 8 point. So our answer for 8.2.1, right? We know the fact that angle B2 is equals to what? Is equals to F2, right? So it's going to be equals to F2, and that is going to be equals to x, and our reason is going to be 10 chord theorem. So we know the fact that that's going to be 10 chord. Hope that makes sense, right? Then we're going to move to the next one, which is 8.2.2, right? So 8.2.2, they want D4. So we see the fact that again, T4 is equals to F2, which is equals to x. So we know the fact that D4, so angle D4, so angle D4 is equals to F2, which is equals to x, and our reason again is going to be 10 chord. So it's going to be 10 chord theorem, right? So it's going to be 10 chord theorem. Yes, it's going to be theorem. It's going to be 10 chord theorem, and here's going to be 10 chord theorem. So we have that, right? So now we're going to move to angle C, which is going to be 8.2.3. right? So we see the fact that angle C. So let's go back. We see the fact that angle C is here. Do you see it? It's here in this triangle, right? So first, we need to prove that this is x. Okay, we already know. We already proved that this is x because that's B2. And we already proved that this is x because this is what? This is D4. We already proved that too. So we know the fact that angle C is going to be 180 minus 2x, right? Sum of angles in a triangle. So let me just show you. So you're going to do this, right? So we already know the following, right? And I'm just going to write it in angles. So what I'm going to do is the following. I'm going to say B2 plus D4 plus angle C is equals to 180 degrees. Then you're going to say sum of angles in a triangle. Then you're going to make C the subject, right? So let's do that. So we know that angle B2 plus angle D4 plus angle C, what they want is equals to 180 degrees, right? And the reason is going to be sum of angles in a triangle, right? So we already know this is x, and also we know that this is x, and this is angle C, so it's going to be 180 degrees. So this is the same as 2x plus angle C is equals to 180 degrees. So therefore, we know that angle C is equals to 180 degrees minus 2x. So let's just go fill it up in the diagram. So this is going to be 180 minus 2x. Hope that makes sense, right? So now we have number, 8.2.4. So we see the fact that angle 8.2.4 right? We're looking for angle A, right? So now let's go back in the diagram and see where A is. We see that A is this one, right? And we see the fact that already we have determined that is that, right? We already determined this is this, right? So I can just write this one because of we already solved it here. So we can say angle A is equals to 180 minus y. Then we can say what our reason is going to be this one. Hope that makes sense, right? So we know the fact that angle A, right, is equals to 180 minus y, and our reason is going to be opposite angles of a cyclic quad. So it's opposite angles of a cyclic quad. So, right, so we have that, right? So we got that sorted. And lastly, they want us to solve this one. We know the fact that this and this are equal because of its angles in the same segment. So let's do that. So we know the fact that for 8 point, so 8.2.5, we're looking for angle what? We're looking for B1, right? So B1 again is that one. So we know the fact that B1, angle B1 is equals to 180 minus y, and our reason is going to be angles in same segment. And that's how you would answer this entire question, right? Hope that made sense. So now we're going to do question 9, right? So we're going to first fill in the diagram, then we're going to answer the questions. So it says the fact that in the diagram below, two circles, right, touch internally. So we see the fact that they both touch internally here at point A, right? So now let's fill it in. So they tell us the first one. So let me just take my highlighter, right? So they say the fact that AB is the diameter on the bigger circle. So we see the fact that AB is the diameter on the bigger circle. So we're going to focus on the bigger circle, right? The bigger circle's diameter. So let me just take my pen. So I'm going to say here on the notes it's going to be bigger. So bigger circle diameter. Right, so we're going to say bigger circle diameter. So now I'm going to just do this. Then so that we can see it clearly, I'm going to highlight it, right? So we know that the diameter is going to be this, right? So they said the fact that AB, so we see the fact that with AB, right, since it's the diameter, we see the fact that it creates a triangle like this, meaning that this angle here, do you see this angle here, is equals to 90 degrees, right? Because that's going to be angles in the semicircle. So we know that angle C, right, is equals to 90 degrees. And our reason is angles in the semicircle. Hope that makes sense, right? So we see that, right? So also we see the fact that another thing, since this is a diameter, right? So they tell us the fact that it's a diameter, right? And meaning this is also the center. So the center is here, and they just say it here. So let me just take my highlighter. We see the fact that L is the center, right? So I'm just gonna do this, erase this, this, right? Because we know the fact that that is 90. We know the fact that this, right, is a radius, which is going to be equals to this also is going to be a radius, right? Then also this is a radius. So since we know the fact that all three of them are radiuses, so this, and this are all equals to each other, right? But the one that I'm looking at, and that's like very interesting, that can give me more things, is this one. Do you see in this triangle, this two? Do you see this and this? Since our radius is going to create a triangle, meaning since it's a radius, this and this are also equals to each other. Hope that makes sense, right? So now let me just mark the fact that all three of them are radius. So we know the fact that what? We know the following. We know that AL, so you know that AL is equals to LC, right? Is equals to LB, right? And they all radius, right? We know the fact that they all radii, right? Then we know the fact that since they're all radii, therefore, right, I know that this angle here is equals to this angle. So I'm going to just make it in a different color. So I'm going to just make it in red. So I know that this and this are equals to each other, right? So I know that angle what? So I know the fact that from there, I know that angle, so let's name it. It's going to be LA, C. So it's going to be LAC is equals to this angle here, which is going to be ACL. So it's going to be ACL, right? Equals to each other. And my reason is going to be what? It's going to be opposite angles equals, meaning what? Meaning opposite. So opposite sides equals, opposite sides equals, meaning opposite angles equals, opposite angle equals. Hope that makes sense, right? So we have that, right? So we have that. So with that said, is that I think we can move on to the next statement, right? So we can move to the next statement where we talk about the smaller circle, right? So let's do that. So let's zoom it in. So now I'm going to change my highlighter. So let me just change my highlighter. So changing my highlighter, it's going to be this one. They tell me that AL is the diameter of the small circle, right? And we know that its center is S, right? So let me just erase this, right? So we know the fact that this is the diameter. So I'm going to be strictly looking at what? At this triangle, right? At this diameter, sorry, properties of this diameter. So it's going to be this one. We see from the smaller circle that I can create a triangle like this, right? So meaning this one is also 90 degrees. So since it's 90, I'm going to match it up with this orange. So I know the fact that this is going to be 90 degrees, right? So I'm going to match it up with this orange. And so I'm going to say this is going to be notes for what? So this is going to be my notes for my smaller circle. So let me just change. I want the darker green, right? So this is going to be smaller circle diameter. So smaller circle diameter, right? So it's going to be smaller circle diameter. Since it's smaller circle diameter, we know the fact that this angle here, right? So let's name it, is going to be ADL. So angle A, right? D. L is going to be equals to 90 degrees, and the reason it's going to be angles in semicircle, right? So we know that, right? Then let's look at the properties of what? Now we're going to look at properties of a radius, right? So I'm going to just erase this, right? So now we can just focus on the properties of the of the radius. We know the fact that this is a radius. This is also a radius, and this is also a radius, right? And we are going to be focusing on this one again, this one. Because we know the fact that if those two are equal, then those two small angles are equal to each other. Hope that makes sense, right? So now focusing on that, I think I'm going to start naming the fact that A is, so we know that A is, right, is equals to what? Is equals to ST. It's equal also to SL, right? So we know that, right? So with that being said, is that we know the fact that the reason is going to be radii, right? Then now I know the fact that this angle here, do you see this angle here is going to be equals to this angle, right? So I'm going to just make it in red because we already know that angle A is in red. So I can just change it to red. So we know the fact that also this is going to be equals to each other, just to match up with everything, right? So I know those two are equals to each other. So we know the following. We know the fact that angle, let's just write it in red, right? So we know the fact that angle A, so it's going to be LAD, or let's just see the fact that what it is so I can match it exactly. So yeah, L, so it's called LA, let's thingy, LAC, no, I want the AL, okay, no, let me just name it here. So we know the fact that angle LAC is equals to this angle here. So this angle here is equals to this angle here, right? So we know the fact that it's going to be equals to ADS, right? And our reason again is going to be opposite angles. So opposite sides equal, meaning opposite angles equal. So that's what we have, right? So now that's what we have so far, right? So now let's look at it. They continue and tell us the fact that S and L is the center. We already established that. And they tell us the fact that D is a point on the smaller circle, right? And C is the point on the larger circle, right? And ADE is a straight line. So that's fine. Then they tell us the fact that what you call this, M, and M is the point on LC such that ML, so we see the fact that we have parallel lines. So now let me just erase this, right, so that we can look at parallel lines, right? So we're gonna look at parallel lines, right? So now we see the fact that now we're gonna look at parallel lines. So they tell us the fact that M, so let's highlight it. So first let's highlight it with a different color, right? They tell us the fact that MN is parallel to LC. So we know the fact that ML, so it's this line, is parallel to LC, which is this one, right? So since it's parallel line, we see the fact that we can create a Z because there's no line going through like this, right? So we can create an F. So we see the fact that from creating an F, we can create an F going like this, meaning now I can say these two are equals to each other. So I know the fact that this angle here is equals to this angle here, right? Then also, if I now erase this part and now extend the F from the opposite direction like this, going like this, I can see the fact that also, let me just change the color, maybe in dark blue. So let me just do this. Dark blue is dark blue is dark blue. Okay, cool. So dark blue. I know the fact that now this angle here, I know the fact that this angle here is also equals to this angle here, right? So that is F. So we see the fact that on the other side, I can create an F here. Okay, I can create an F there, right? So now let's go into the other side. I can actually create an F again. So let me just erase this F here. So, but do you see the fact that on the other side, I can create an F like this? Do you see that? Because parallel lines. So meaning now, let me just pick another color. So let's pick this one, right? We see the fact that this angle here is also equals to this angle here. Then I think everything that is related to parallel lines is sorted now, right? So now let's put them down, right? So we have the following. So I'm going to name it because it's in blue, dark blue, right? I'm going to name it. So we know the following. We know the fact that for MN parallel to LC, right? So let's put a highlighter, right? So we know the following. We know the fact that angle L, so this angle here, right, it's going to be equals to this angle here, right? So we know the fact that that is what? That is going to be CLB, right? It's going to be equals to N, right? It's going to be NMB. And our reason for that is going to be what? Corresponding angles, right? Corresponding angles. Then we're gonna have another one. Do you see this angle now? Now I'm looking at it from this and this, right? So this one is gonna be NML. So it's gonna be NML is gonna be equals to this angle now. Remember this angle, which is gonna be CL. So CLA. So it's gonna be CLA, right? And again, it's going to be the same reason, corresponding angles. Then now we're going to look at this one, right? So looking at this two, it's going to be the other one is going to be LC. So it's going to be LCN. So it's going to be LCN, right? Is equals to what? To M. So MNB. So MNB, and again it's going to be the same reason, corresponding angles. So hope that makes sense. So now our diagram is completely full. We can go answer the questions now. So now what we're going to do 9.1. It says we need to prove that, let's highlight what they want. DL, so DL is this one, so in red, DL is parallel to CB, so this lines, right? So we need to prove that those two are parallel lines. So first we can prove alternating. Do you see the fact that we can prove that alternating? But with alternating, we need to prove that this one and this one are equals to each other. We don't have enough information, right? So the other one is corresponding, meaning if I draw a line this side is that I need to prove that this. So if I prove it, if I draw it this slide, is that I need to prove this one and this one are equals to each other. Again, that is not enough information, but I see the fact that if I draw the F this side, right, is that I see the fact that this is 90 and this is 90. I already proven it, right, by labeling it. So therefore, we know the fact that if I say both of them are equals to 90, that is corresponding because both of them are going to be equals to each other. Hope that makes sense. So the F that I'm going to use is going to be from this side like this, right? So we see the fact that this and this are equals to each other, right? So we already know why they're equals to each other. Do you see the fact that we know the fact that angle what? Angle C is D, is 90 degrees, and we also prove the fact that this angle is equals to 90. So taking both of them, we're going to say both of them are equals to 90. Therefore, those two lines are basically what? Are basically parallel to each other, and the reason is going to be corresponding angles. So now let's do that, right? So taking the first one is, we know the fact that angle C, so we know that angle C, right, is equals to 90 degrees, and the reason is going to be what? It's going to be angles. So it's going to be angles in semicircle. We also know that angle A, so ADA, so it's going to be ADL, it's going to be equals to 90 degrees, and it's going to be angles in semicircle again. Right, so therefore we know the fact that angle C is equals to angle ADL, right? Therefore we can conclude that DL is parallel to CB, and the reason is going to be what? This, we use corresponding angles, so it's going to be corresponding. So it's going to be corresponding angles. Hope that makes sense. So that's how you would answer this question. So now we're going to go to 9.2. It says we need to prove that 2SD is equals to LC. So we need to go back to the diagram so we can be able to prove that, right? So SD, so let's see SD. So we see the fact that SD is this one, right? So we see the fact that SD is this one, right? And LC, we see the fact that LC, so wait, LC, we see the fact that LC is this one. So we need to find the relationship between LC and SD, right? So now let's just look at it, right? We know the fact that SD, right, is what? Is a radius, right? And if just looking at this circle, right, the small circle, right, is that we know the fact that SD is a radius, and also we know the fact that we know the fact that AS is a radius, and also this one is a radius, right? But the most important thing, we already know the fact that LA is a radius, right? LA is a radius of the big circle, which is also equals to this one. So we know the fact that this one is equals to this one, but very important, this one is equals to 2 times of this one because of their both radiuses, right? So since we know the fact that this is equals to 2 times of this one, it proves what we already want, right? So now let's circle it back. So what I'm going to do is that I'm going to prove, right, the following. We're going to prove the fact that this and this are equal because they radius. We already proved it, remember, in the smaller circle. So what I'm going to prove is that 1 and 2 are both radiuses, right? Then I'm going to prove that this whole one and this whole one are equals to each other because they're radiuses. Then we know the fact that this, right, then we're going to basically, we know the fact that this and this, since they both radius, I can write this one in terms of, I can write this one in terms of this one. Hope that makes sense, right? So let me circle it back so that it makes sense. So I'm going to start with basically proving that there's 2 are radiuses, right? So let's prove that, right? So we know the fact that LC, because of that's what the question wants. So we're going to start with LC, right? So we're going to say LC, right, is equals to what? So LC is equals to LA, right? And they both radius. So we know the fact that LC is equals to LA. So it's equals to LA, and the reason is radius, radii. Hope that makes sense, right? So now I need to be able to write LC. I need to be able to write LC in terms of SD, right? So now let's find the relationship between them, right? So we know the following. We know the fact that L LA, right? LA, right, is equals to what? To SA and LS, right? So we know the following. So I'm going to take LA because already we have matched it up with LC. So we know the fact that LA is equals to what? Is equals to LSA. So it's going to be SA plus what? Plus what you call this? Plus SL. So it's going to be SL. Right? So we know that, right? So we know that we don't need a reason for that one. We don't need a reason, right? But we know something, right? Remember the fact that I want anything in terms of what? Of SD, right? But we know the following. We know the fact that what you call this? SA, SL, and LD are all equal to each other. We wrote it here when we were doing the smaller circle, right? See, all three are equals to each other, right? So we know the following. We know the fact that SL, so we know the fact that SD, basically, let's start with SD so that there's order. We know the fact that SD, right, is equals to SA plus, sorry, not plus, equals again to SL, and the reason is radius, right? So since all three are equals to each other, meaning I can now write LA in terms of what SD, what they want in the question. So I can write it in SD, how they want it in the question, right? So now let's do that. We know the fact that LA now is equals to, sorry, let's go down, right? We know the fact that that is going to be equals to SD plus SD. Reason is that, remember that SD, right, is equals to, see, they all equals to this two. All of them. They equals to SD, basically, right? So meaning LA is equals to 2SD, right? But we know the fact that there's two, but we know, so let me just write it, but we know that LA is equals to what? But, remember, so, but we know the fact that LC, which is what we want, right? But we know that LC is equals to LD, right? So therefore, we know the fact that 2SD is equals to LC, right? So that is exactly what they want us to prove. So that's how you would do this question, okay? Okay, now we're gonna do 9.3. Again, we're gonna label what they want from us, right? So they say we need to find SL divided by AB. So we're gonna do mark SL. So SL is this one, and AB is this whole one, right? So we need to find the ratio of these two, right? If I name SL into R, so we know the fact that that is R, we know the following, right? We know the following. We know the fact that this and this, so we know the fact that this and this are both R. So this side is also R because of that's also a radius, right? So we know that. But we also know the fact that, meaning this portion here, do you see this? Just this portion here, right? It's going to be 2R, right? But we know the fact that this 2 and this one are both radius of the big circle, meaning this is also what? This is also 2R. So meaning this whole thing is 4R. So we know the fact that this one is also 2R because they equals to each other because they are both radius of the big circle, meaning the whole AB is 4R, right? So that's what we have. So what I'm going to do it is that I'm going to basically name R, right? So I'm going to let SL equals to R. Then from there, we're going to take it from there, right? So let's do that. So I'm going to say let SL equals to R, right? So we know that SL is equals to R. Then we know the fact that we know the following. We know the fact that SL, right, is equals to SA, right? And that's going to be equals to R. We can say proven because we already proven it in the previous question. So it's already proven, right? So again, we also know the fact that therefore, meaning therefore, right? Therefore, that means the fact that LA, right, is equals to SL plus SA, right? So then this is going to be equals to what? 2 R plus R. So therefore, LA is equals to 2R, right? So we already proven that. So now we have that, right? We have the fact that that is 2, what you call this equals to 2r, right? Then we know the fact that we know the following, right? We know that LA, right, the big one, so I'm looking at this one, right, is equals to this one, and I'm going to say radius, so that 2, so it's going to be equals to LP, and the reason for this is going to be radius, radii, right? So we know that, right? So we already know that LA or AL, right? So we know the fact that therefore LB is also equals to 2R, right? So therefore we know the fact that AB, right, this whole one is 2A plus 2A. So we know the fact that now, therefore, we know that AB is equals to what? Is equals to AL. So what I'm saying is equals to LA and LB. So that's what I'm saying. It's going to be equals to LA plus LB. So both of them are 2R plus 2R, right? Which is going to give me 4R. So what I'm going to do is that I'm going to highlight AB and this SR, right? So remember the fact that we're looking for what? Our calculations, we're looking for SL, right, divided by AB. So I already say the fact that SL is in terms of R, so I'm going to name it R. So I'm going to say R divided by 4R. So this is going to be the same as the R are going to cancel out, so it's going to be 1 over 4. So that's how you would find the ratio of SL divided by AB. Hope that makes sense, right? So that's how you would answer this question. So now we're going to do 9.4, right? It says determine the length of LM. So again, I'm just going to highlight it in red because we know the fact that we need to find that. So it's going to be LM. Wait, LM is here. So we need to find that length, right? So they give us the fact that AB, so I'm going to put it in green, right? Or let's put it in blue. We know the fact that AB, which is going to be this one, they give us equals to 30 units, right? I'm writing 30 units because of the other one, the other information that they gave us in terms of it's a ratio. So I want to differentiate it, right? So we know the fact that that is equals to 30 units, right? So since it's equals to 30 units, there's something important that we know. We know the fact that AB, right, is made out of what? It's made out of A, L, and B, L, right? And both of them are radius. And since they gave us the diameter, right? So half of a radius is basically going to be half of this. So meaning this portion here, so I'm going to just mark it. So this portion here is equals to 15. And also this portion here is equals to 15. Because it's half of a diameter and our diameter is 30. Hope that makes sense, right? Then just one more thing. They gave us the fact that they gave us the following. They gave us the fact that BN, right? BN is BN divided by NC is equals to 7 over 9. So BN, right, divided by NC is equals to what? Is equals to 7. And this is 9. This is not units, this is ratios, right? So that's that. So now we need to prove that this one, we need to calculate the value of this one. We see the fact that we have parallel lines, right? You see the fact that we have parallel lines, so we can use proportionality theorem on this triangle. So let's highlight that triangle in purple. So we're going to use this triangle. So I'm going to just highlight this triangle. So this triangle. So we're going to use that triangle, right, to calculate our LM, right? So now what we need to do is that, what do we have, right? What information are we given, right? So we know the fact that we're given this 2, right? And we're given this whole length of this side. So I need to be able to use this 15. So I'm going to use this 15. So I'm going to need to find this side corresponding to the other side, meaning it's going to be this side. Then what we want is this portion divided by this portion. Hope that makes sense. So now, since we're going to need this entire thing, let's calculate what is BC, right? So we see the fact that BC, right, it's going to be what? It's going to be 7 plus 9, right? So it's going to be 7 plus 9. So when you say 7 plus 9, what are you going to get? You're going to get 16, right? So we see the fact that BC is 16. So now using the proportionality theorem, so we know the fact that we're looking for what? We're looking for this one. What corresponds to that one is this one. Then we're going to use the whole side because we have this 15, which is going to correspond with this side. Hope that makes sense. So we're going to say what? We're going to say LM, which what we're looking for. It's going to be LM divided by what? It's going to be LM divided by LB. So it's going to be what? LM, right, divided by LB, right? So we have that. So this is going to be equals to, then remember the fact that LM is correspond to this one. So since we started with LM, we need to take the corresponding, which is going to be CN. So it's going to be CN divided by LB corresponds with what? With BC. So it's going to be divided by BC. So we know the fact that this is going to be LM. We know the fact that LB, right, is equals to 15 units. And we know the fact that CN, right, so CN is equals to 9 divided by what? Divided by 16, right? So now we can solve for LM. So cross multiply, so it's going to be 16 LM is equals to 9 multiplied by 15, right? So when you say 9 multiplied by 15, so it's going to be 16 LM is equals to what? To 135, right? So LM is going to be equals to 135 divided by what? Divided by 16. So sorry, very important, I forgot to write the reason here. So we know the fact that this is going to be proportionality theorem, right? Proportionality theorem. And don't forget to write which lines are parallel to each other, right? So we see the fact that LC, so the parallel lines, remember the parallel lines is LC. So this is the parallel lines, right? LC is parallel to MN. So it's going to be parallel to MN, right? So now we can continue. So therefore, LM, right, is going to be equals to what? It's going to be equals to 8,44 units. So that's how you would solve this question. Okay, now we're going to do question 10. So with question 10, we're going to fill in the diagram. Then we're going to answer the questions, right? So it says the fact that in the diagram below, triangle P, so PTQ, right, is drawn. So we see the fact that it's PTQ, right? So that does not mean the fact that this is the diameter, guys, right? This is just a triangle drawn, right? And they tell us that O is the center. So we see the fact that O is the center. So meaning if O is the center, then we know the fact that this and this are equals to each other, right? Because they both radius, right? So we see that, right? So we see that. So let's just fill that in. So we know the fact that the following. So we know the following is that I'm going to say O is the center. So let's do this. O is the center of the circle. So we can fill it in, right? So red. So we know that O is the center. O is center, right? So since O is the center, we know the following. We know that this and this are equals to each other, right? So we know that OP is equals to OQ, right? And the reason for that is radius. So we're going to say radii, right? So we know that, right? Then we know the fact that the line from center, right, going down, it's going to cut the chord and it's going to create 90 degrees. That's theorem 1. So this is going to be 90 and this is going to be 90, right? So line going from here, it cuts the chord and this is going to give me 90 degrees, right? So that's theorem 1. And because of this 2 by 6. Hope that makes sense, right? So we know the following. We know that angle D1 is equals to angle D2. And both of them are equals to 90 degrees. And the reason is theorem 1. So the theorem is, the reason is going to be line from center, right, to midpoint is perpendicular. So we have that, right? So we have that. Then now, since we know the fact that, remember the fact that these two are equals to each other, so meaning this creates a triangle. So meaning P1 is going to be equals to this angle here at Q, right? And the reason is opposite angles equal, right? Opposite sides equal, opposite angle equal. So we know that angle P, so this angle and this angle equals to each other. So we know that angle P1 is equals to angle. So this angle, let's name it, this one. It's going to be TQP. So it's going to be T. So let's name it, right? So we're going to name it. It's going to be O. So no, it's going to be, we can start at OP, right? So I'm going to say TQP, right? It's going to be equals to what? They're going to be equals to each other. And the reason is going to be what? It's going to be opposite sides equal, right? Means that opposite angles equal. Hope that makes sense, right? So we see the fact that we have everything that we need here, so we can start like answering the question. So now we're going to do 10.1, right? 10.1, that they say that we need to prove that angle A3 is equals to angle QPT. So let's go back, right? So A3, we see the fact that it's here. So let's put it in the highlighter. So in blue, so we need to prove that this angle, right, is equals to Q. So if we start from QPT, so this angle here, so this whole angle. So we see the fact that we need to prove that these two are equals to each other, right? So we see the fact that there isn't any initial relationship, but we see the following, right? Is that if we create, and I'm just going to make it in yellow, if we create a cyclic quad like this, right? If we prove that this is a cyclic quad like this, right, then we can prove that this is exterior angle of a cyclic quad, right? So we can prove that these two are equals to each other, exterior angle of a cyclic quad. But remember the fact that when we were making our properties, when we're filling in, right, we can actually prove that that is actually a cyclic quad, because do you see the fact that this and this, when we add them together, because this is 90 and this is 90, and when we add them together, it's going to be 180, because we know that opposite angles of a cyclic quad are what? Are both, what was opposite angles of a cyclic quad are equals to 180. So since this is 90 and this is 90, 90 plus 90 gives us what? Gives us 180. So that proves that this is a cyclic quad, and the reason is going to be opposite angles of a cyclic quad. So therefore we can prove this. So let's start. So we're going to prove that the yellow one is a cyclic quad, then we can conclude that this two are equals to each other. So let's do that, right? So step one is proving. So step one is proving what? Is proving. So we're proving that what? We're going to be proving that this is a cyclic quad, so which is PTDO, right? So we're proving that PTDO is a cyclic quad, right? So we're proving that PTOD is a cyclic quad, right? So we know the following, right? We know the fact that angle T is equals to 90 degrees. And that is good because this is just given. So we know that, right? So now we need to prove that angle D1 or D2, it doesn't matter. So I'm going to prove that angle D1 is equals to 90 degrees, right? And I already know because of its line from center to the midpoint, right? So we know the fact that that is going to be equals to 90 degrees, right? So we know that that's going to be equals to 90 degrees, and our reason is going to be line, right? From here, remember, line from center, right? Line from center, right, to midpoint is perpendicular. So we know that, right? And we know the fact that the following, we know the fact that angle T plus angle D1, right, needs to be equals to 180 degrees, right? And we know the fact that that is true because of 90 plus 90 is equals to 90 degrees, right? 180 degrees. We know the fact that that 2 is equals to 180 degrees. So therefore, since that's the case, right, we know the fact that PTOD is a cyclic quad. So it's a cyclic quad. And the reason why it's a cyclic quad, we're going to say what? Opposite angles. So opposite angles of a cyclic quad. So that's our reason. So opposite angles of a cyclic quad. Hope that makes sense, right? So now, since we've proven that it's a cyclic quad, we can say the angle that they want. So therefore, we can conclude that angle O3 is equals to QPT, right? And the reason for that is going to be exterior. See, those two are equals to each other, the blue ones, and it's going to be exterior angle of a cyclic quad. And that's how you would solve this question. Hope that makes sense. So now we're going to do 10.2, right? They say we need to prove the following triangle. So let's highlight those two triangles. So we need to prove that triangle OPD. So it's O. So it's going to be from O to P, right? So we need to prove that OP, right? Then it's going to be from OP and what you call this, PD. So it's going to be this one, this line. So let me just fix this for a moment. So let me, oh my god, okay, wait. Let me just erase this and just do the 90 degrees like this. Right? So it's going to be like this. So it's going to be like this. Let me fix this. Yes. So I can fix this. Then finally, it's going to be this one. So this triangle, this purple triangle, right? We're proving that this purple triangle is similar to triangle. So let's make it in another color. So I'm going to make it in orange. So it's similar to PQ. So PQ is going to be this one. Right? So again, let's fix that. So it's going to be PQ, right? Then PQ, then QT. So it's going to be from here to here. Right to here. So we're proving that the purple one is similar to the what? Is similar to the orange one, right? So that's what we're proving. We see from this is that this and already this are equals to each other, right? It's opposite angles over like opposite angles equal, opposite sides equal opposite angle. Then we see the fact that this is 90 and also here in the purple one this is 90. Then the last one, which is this one, right, is going to be equals to the whole of this one, which we know the fact that that is what that's going to be sum of angles in a triangle. So we already know that we have all three sides, right? So we're going to say what? We're going to say in, so black, so we're going to say in, there's two triangles, triangle OPD, right, and triangle PQT, right? So we know that, right? So the first one is that we're going to basically look at the one that is basically what we have. So we know the fact that we have proven that angle D1, right, in the previous one, that angle D1 and T and angle T, what you call this, and angle T are both equals to each other. So we know that angle D1 and angle T are what? Are equals to each other because they both equals to 90. And the reason for this, we can say proven. Right? So this is what? Angle T is this 90 degrees and this one. They both equals to each other, right? Because they both equals to 90. So that is sorted, right? So number 2, so I'm going to name it number 1 and number 2 for statement number 2, right? We know the following. We know the fact that this 2 are radius, right? So we need to prove that this is radius so that we can prove that these two are equals to each other. So we know the fact that PO is equals to QO, right? And the reason for this is going to be radius, right? So therefore, we can prove that angle P1, which is what we want, is equals to what? Is equals to angle P, what you call is PQ, right? PQT, right? And the reason for that is going to be what? Opposite sides equals. Opposite sides equals means opposite angles equals, or isosceles triangles equals, right? So that's what we have, right? So now we know the fact that that's that. Then now the remaining angle. So the remaining angle that we have now is going to be what? From the small one, it's going to be O2, right? And from the big one, it's going to be this whole one. So it's going to be QPT, right? Is the big one. That's the remaining one. Always is that just make sure the fact that you prove two angles, then the remaining angles, you can say sum of angles in the triangle, right? So number 3, statement number 3, remember you need 3 statements to prove. So it's that angle O3 is equals to angle QPT, right? And the reason is going to be sum of angles in a triangle. Sum of angles in triangle. Right? So now we have proven this question. So therefore, we know the fact that triangle OPD and, right, triangle PQT, right? And the reason, okay, triangle LPQ is similar, forgot to say similar. And the reason for it here is that they all angles, we all proven angles. So it's going to be what? It's going to be angle, angle, angle. And that's how you would basically solve this question. Okay, now we're going to do 10.3. It says QOQ multiplied by QT is equals to 2PD squared, right? So the minute you get such equation, it's two ways that you need to prove it. Is that if you're already proven that two triangles are similar, is that you need to use that. Sometimes is that you have a situation where you have similarity, like you've already proven that two triangles are similar. Then also you have like parallel lines, meaning it's proportionality theorem, right? So what we're going to do in this case, right, is that the only one that we have is similar triangles, right? And I like pulling out my triangles from the diagram so that I can see them properly, right? So that I can match the side and know who's equals to that, right? So I'm going to pull out the orange one. So we're going to start with the orange one. So we're going to pull it out. So the big one, which is going to be orange. So it's going to be like this, right? So let's name it. We know the fact that this is going to be 90 degrees, right? And when we name it, this is going to be what? This is going to be P, and T is at 90 degrees. And this one is going to be Q, right? So we know that, right? So we know the fact that that triangle is similar to this triangle, the small one. So it's going to be the small one, right? So it's going to be this one, right? And this is going to be 90 degrees here, right? So from here, we know the fact that the 90 degrees from what we have proven, right? We know the fact that 90 T and D1 matches up. So this is going to be D1. So this is going to be D1, right? Then we know the fact that P, right? So we know the fact that our P1 matches up with our Q, right? So we know the fact that P1 matches our Q. So it's going to be this one because it matches up with our Q. So our P1 is going to be here, right? Then lastly, right, from our triangle, it's going to be what? We have DPQ. Then the last one is O, but is O2, right? Remember the fact that it's going to be O2. Where is O2? So it's not O2, yes. Why did I say O3? I am so sorry about that. So this is O2. Yes, it matches up with O2. Hope that makes sense, right? Sorry for that O3, right? So now we have that, right? So now we have that, right? So since we have that, is that now we know the fact that we need to matches up the angles. So this one and this one are equals to each other, right? And this one at the top matches up with this one, right? Reason is that when we're using when you're using similarity, we need to match the sides with the angles, how the angles are, right? So now we look at the information that they gave us, right? They tell us the fact that we need to prove this, right? So the easiest way is to take your highlighter, right, in your new diagram that you took out and mark what we have, right? We see the fact that they say what? They say, OQ, right? We see the fact that from here we do not have OQ. Also, we do not have OQ here, but we're gonna look from the original diagram, right? Highlighted. So we see the fact that OQ, so OQ is this side, right? We have OQ there. Then they tell us the fact that OT, right? So from the big triangles, OT, right? So we see the fact that it's OT. Then on the other side, they tell us the fact that it's PD. So we see the fact that that is PD, right? So now we need to find the relationship between this OQ and one of the sides here, right? We see the fact that if we zoom it in, right, that OQ is actually a radius, meaning it's equals to PO. So meaning this is also equals to this, right? What we want. So meaning another side here, since those two are equals to each other, so it's the same as using this side when we're going to use similarity, because we know the fact that these two are equals to each other. Hope that makes sense. Reason why I'm doing this is that we need two sides in either of the triangles so that we can create a ratio to create this. Hope that makes sense, right? So we see the fact that from here, our O2 matches up with this because they both equals to each other because of the radius. So therefore, in this side is that I'm going to use this side and this side. And this side, I'm going to match it up. We already know that this side and this side matches up. Do you see the fact that it's this because of the double lines, and here's a double line until 90. So this 2 matches up, and this one matches up because of, do you see, this and this and this and this. Hope that makes sense. So now I can create what? I can create my ratio, right, to basically solve this. So now let's do that, right? So we're going to start with what? I'm going to just talk about this relationship first, right? So this relationship and this relationship, right? Because it's from this diagram, we know the fact that that is what? That is basically equals to 90. Hope that makes sense, right? So we know the following. We know that OP, right, is equals to QO, and the reason is radius, right? And the reason is what? Is that in both of the triangles, you need to find 2 sides so that you can create the ratio, right? If one of them you find 2 sides and the other one, you know the fact that you can easily match it up, right? Hope I haven't confused anyone, right? So now let's make the ratio, right? So we know the fact that in our ratio is OQ, so we start with OQ. So we know that OQ is QO, right? So we're going to say OQ, right? So it's going to be OQ, right? Divided by what? Divided by who matches up with OQ. So we know the fact that OQ, right, divided by PQ, right? Because we know the fact that it's going to be this side divided by the other side, right? We know that OQ matches up with this one because of, do you see the angles are the same? So it's going to be what? PQ, right? And that's going to be equals to, on the other side, we need PD, right? From what we have highlighted, we need PD. So we know the fact that it's going to be PD, right, divided by who matches up with PT is QT. Hope that makes sense, right? And the reason for this is going to be what? It's going to be the similarity, right? It's going to be because triangle OPD is similar to triangle PQT, right? So we know that, right? So now, since we know that, now we're going to cross multiply. So this is the same as OP, right, multiplied by QT, right, is equals to what? Is equals to PD multiplied by PQ, right? So we know that, right? But we already know the fact that we don't need OP, right? We need QO from the question, right? So I'm going to replace this by this, right? So let's do that. So it's going to be QO multiplied by OT is equals to PD, right, multiplied by PQ, right? And now, do you see the fact that we're one step closer because of we already have this side, which is this side. Now I need to sort out this side. We have one PD, so we need to get rid of this one. So let's find a relationship between PQ, right, and PD, right? Because we need to have a relationship with that, right? So let's go back to the diagram. Where's PD? So PD is this one. Maybe let's look at it from this diagram, right? So from this diagram, we see the fact that PQ, right? PQ. So we see the fact that PQ, so it's going to be this whole one, right? PQ is made out of what? It's made out of PD and DQ. But we know the fact that we were given that PQ and DQ are equals to each other, meaning this can be replaced by PD, right? So meaning this can be written by what? By PD. So we know the following. So let's do this. We know the fact that the other side P, but we know that PD, right, is equals to what? Is equals to PD, sorry, not PD, right? We know the fact that PQ, right, this whole side is equals to what? Is equals to PD plus DQ, right? So we know that PQ is equals to PD, right, plus DQ. That is perfect. But we know the fact that PD is equals to DQ, and the reason for that is that it's already given. See, it's already given, and we can even go up in the statement, right? It's already given. So this too, it's already given, right? It's already given. Hope that makes sense, right? Since they're equals to each other, I can replace this DQ by PD, right? So we can do that. So it's going to be the same as PQ is equals to PD plus PD, right? So PQ is equals to 2 PD, which is what we want, right? We want just PD. So now I'm gonna rewrite this updated. So therefore we know the factor OQ multiplied by QT is equals to PD multiplied by what? PQ is going to be replaced by 2 PD, right? So now this is going to be QO multiplied by QT is equals to this multiplied together. So it's going to be squared. So it's going to be 2 PD squared, right? So that's how you would solve this question.